Audio? Good. All right, here we are. My glucose level sucks right now. It's like in the stratosphere because I had the audacity to eat a sandwich. Oh well, happy Friday. Chat's lively as usual. I got all that code, by the way. All the code's back. I'll go over it a little bit when we start, just in case I delete it again. I need to transcribe it another time. There might be a couple missing semicolons. We gotta kind of take a look at it. The compiler's not exactly as awesome as it could be. It's not an Arduino compiler. You know, we get the QMS compiler. It'll tell us if some stuff is wrong, but I don't think it'll do. It didn't catch a bunch of stuff that I did wrong in the other code. So we'll just have to use a fine-tooth comb and make sure that my code is good. The Twitch IDE is ever vigilant. I had to go through that VOD yesterday. Man, I look tired. I need to get more sleep. I still look tired. I got like 12 bags under my eyes. Before I do anything, make a copy. Yeah, I should do that. I should probably do that. We'll spin it off into another folder. Because, yeah, I spent last night transcribing. I understand the code a little bit better now, though. That's a good part. Actually have some semblance of what's going on. We'll see about stream tomorrow. I do want to do a stream tomorrow. I want to keep up the momentum, you know? But I'll have to see what we're doing. I might want to do my summer car with the wheel and the shifter. Maybe not even do the the rally. I don't know. Here we go. Yeah. What's up, this Daphne? And Celia Russell. How you guys doing? I need to do a beard trim. I haven't touched my beard in a little while. It's starting to get a little too mountain man-y. And then this happens because I can't see anything over there. It's like creeping. Anyway, try to ignore that. I had a good long look at my face yesterday because I deleted all of the files that we spent all fucking stream programming. And then I had a cut-paste thing where I cut-pasted the wrong direction. And I Control-Z'd myself into a corner. And then when I was looking for the redo button on the Windows UI, I hit the new folder button. And it deleted all of my redo steps. So all my code just gone. I tried to use some file recovery tools, but that didn't really work. I just had to sit down and start programming. I had to look at my VOD and then look at what I showed on the VOD in order to get all of my stuff back. I did though. I got it all back, and it's better as a result. I organized it a little bit more. I learned a little bit more about the code. So hopefully we can get a keyboard functioning today. And I can actually do stuff with my hands instead of programming. That's what I'm hoping to do. I want to get all the hardware done on this thing because that's the fun part. Corgi updates. She's very bitey. She bite all the time. That all she do. She like to bite. Uh-oh. Wait. Oh. Fucking. Okay. I'm just focusing. She bite me. Yeah, I was greeted by puppy teeth. Oh yeah, that's a picture where she's actually biting the camera. There she is, little gremlin about to attack me. Be cute. That's my dinner. that was a gumbo with some okra that somebody had given us, and it was very woody. Yeah, she's extremely cute. Look at her little legs. Those little legs. She's so cute. She bite though. Look, it's the only time I've touched her that she hasn't bitten me. I haven't documented. Yeah, she's a little corgi. You got little ears. I'll get her on stream eventually. I could have done that if I was recording properly. I could have gotten a good a good video of her just munching into the camera, because that's what she did immediately after the one photo with the ear up. She lunged at me and basically bit the camera lens. She's been like nomming my phone whenever I have it out. So I'm trying to train her to not be as bitey, but she's a puppy, so it'll happen. How's everybody doing? Happy Friday. The dinner was also adorable. Gumbo over rice. It was good though. But yeah, that okra, you have to like pick out the fibers from it. I guess that's just okra. Okra can cure diabetes. You just soak it in water and then you drink the okra water or something. There was like a meme of that. It was like something somebody actually posted. It cured my diabetes with okra water. It's like, what? Huh? Overestimated my soldering skill? I've done this. 0.1 millimeter wire. Ooh. That's pretty awesome, actually. You gotta have really good magnification and a really sharp iron tip, and you can do really good. You could do that, Celia. I know you can. You just gotta be at a comfortable height and be able to get your whole hand stabilized. Actually, the way that we would do the super thin stuff is to dip it in solder paste, and then it has exactly the right amount of solder and flux on it, and then you can just barely like sneak it in there. Fridays are better because work from home. I used to have to commute 45 minutes to get to the office. Yeah. And then go through military security to get in. Unfortunately, I wasn't able to work from home from that job. I mean, clearly. Flood of the wire and solder. Yeah, you gotta like tin it separately and then bring it over. But like 0.1 millimeter. Ooh. That's really thin wire. What do we got going on here? Let's see, I got the FTL soundtrack going for a little bit until we decide to start. I got my code squared away. We have the circuit mostly there. It'll need a couple little things. We need pull downs on the pinouts of this thing too. But I want to get the code compiled first and see if we can load it up into this thing. And then we need to do always enable on these guys. I think we're in decent shape. I got my fix-it mug. Yeah. Right out of Satisfactory. An hour drive from school. Oh, LA traffic, yeah. Yeah, this was a reverse commute in DC. So I would leave the city and then I would end up south at Quantico military base. And it was just pain. It was so bad, especially in the winter when you'd leave for work in the dark and then you'd get home in the dark as well. You wouldn't even see the sun at all that day. Pretty color on it. Yeah, they spent a lot of extra care to make sure that, oh, it looks like there's a little aberration on the paint on this one, unfortunately. They spent a lot of extra care to make sure that they found somebody to make a mug that was just like the one in the game. So I had to sign up for it. Yeah, there's a little oof right there. Just a little oopsie on the paint. Little tiny oopsie on the paint. That's okay though. It's very thin though. It's a very thin mug. I fear for its safety. It's mostly just a decorative item, I think, because this is very thin. I mean, yeah, it's like that. So I fear it around hot liquids, but it I mean, everything looks glazed in. Hopefully this doesn't, you know, peel or anything. It doesn't. It seems like there's a glaze over whatever the labeling is, so I think it'll be in good shape. But yeah, I gotta be careful washing this. Yeah. I haven't put any hot liquids in it either. That was the wrong camera. I hit the button for the wrong camera. Stop looking at me so closely. What are you doing? Yeah, I was doing 45 minutes either way. It was 90 minutes in the car a day. Ugh. As much as I love driving, that's a little bit, that's like exposure therapy for driving. Buy Zelda Cup in Japan. Ugh. So it's really not that well made. Yeah. I had a really great mug that was like this miserable face, and when you pour coffee in it, it would do the reveal and it would be this happy face. And I think it got sent through the dishwasher one too many times, or at all. I don't think it should have gone through the dishwasher at all. And it just became a happy face mug from then on. There's also a really great mug where it's got all the original Star Trek away team on the transporter bay. And when you pour coffee in it, one of them, they disappear from one of them and then they reappear on the planet side, which is pretty cool. That one makes the rounds on the memes every now and then. Boop, 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 boop. It's Friday. We're hanging out. I would have been playing with lasers today if we didn't royally and completely fuck up on getting files into microcontrollers. But we're here now, and I've got all the files back. I spent a little bit of time with the VOD transcribing it, so we're back into keyboards. It's been a week and a half. Yeah, the royal we, yep. You gotta use the royal we. It absolves you of any sort of guilt of being stupid. But yeah, so we can now load code into microcontrollers, and I'll go over just a couple of the little things that I changed just to make sure that we see on screen all the code, so that if I screw it up again, I can transcribe it again. I don't think we need this anymore. We're basically, oh yeah, this, hold on, close that. I guess don't save. And then I need to reopen some of the stuff. Oh my God, so many folders. So many folders are open today. What is happening? Keyboard overhaul stuff. QMK home. Just make a quick little compressed folder of all the files there. Now it's all backed up. I think we're in good shape too. Here, let's just start the stream. I like to let people gather ahead of stream, but I don't have a lot to talk about. I mean, Jesus Christ, the news cycle. We all know what's in the news cycle. God damn. And it's all about Thurston Waffles passing away 2 days ago. Poor kitty. But Thurston will live on in our hearts and minds and in the memes. Let's see. But I need to get the music out of here, which I need to find the folder for that. Oh, there it is. Everything, I've got so many folders open that I just can't keep it straight at this point. I literally just explained this, but I'll explain it again because wait, Control-Shift-T. I need to keep that up. I need to keep that up in case I need hold music. I'll explain it again. I'm not above that. So yesterday I screwed up. We saw it. I tweeted it. What happened was I copied files in the wrong direction, wrote over some files, Control-Z'd myself into a corner, went to hit redo to get it all back to where it was. And in doing so, on the Windows UI, I hit a new folder button. And so that deleted all of the redo history, which is a weird thing to have happen. And it's funny how much fucking nerds will lord that kind of shit over you. You make a dumb mistake, everybody rubs your face in it. You got to know that. Especially with tech people and the type of people that would watch my stream. They really rub your nose and stuff like that, even though it was an honest mistake and it's literally never ever happened to me before. It was just like this perfect storm of UI elements and me being on camera and tired. That did it, and it was just a dumb little thing. Oh, you don't run images on your file server? Oh, you don't have backups enabled? Oh, you don't have keyboard or clipboard history enabled? Oh, you don't have photo rec configured properly? Oh, you don't have all these layers of things that I just don't do that that apparently affected me. But anyway, luckily I was recording the whole thing on cameras, so you guys got it in 1080p, 60 frames a second. So did I. I moved the recording into the folder, sat down at my desk over there with a pot of coffee, and I think it took like an hour and a half maybe to get all the stuff transcribed and into new files. And I know the code a little bit better now because I've been over it line for line. Yeah, imagine not having a second computer sitting next to your computer that backs up your computer constantly, minute by minute. Shit happens, you know, shit happens. Notepad++, I need to enable the backup feature on it, I guess. And then I probably need to schedule a image job that'll happen an image task that'll happen periodically on the server. And then the other one is talking about like getting GitHub working. But yell at the cloud. I don't, no, this isn't an old man yelling at a cloud. This is just somebody complaining about how annoying computer nerds are. Custom chip from Amiga before they made it into a chip. No, it's not. No, that's not. That's not what that is. I don't think. The big wiring mess is a different project. The big wiring mess project. That's what you're looking at. There it is. That's the picture that you sent me. See this? That's not an Amiga. That's the big wiring mess. I can recognize it from 5 miles away in a storm. Big mess of wires. Back in April, Roku Future Yellow. Maybe it is. Maybe it is actually an early Amiga. Where are we talking about the big mess of wires? We're not talking about it. Yeah, with Git, you can do version control in any folder without having to bother with GitHub. Right, but I don't know. Big Book of Hardware, Angus chip, Amiga. So is that actually Lorraine? Oh my God. So, okay, so this is Lorraine. Oh. Well. I have been proven wrong. I've been proven wrong. Pretty cool. So it's a totally different project using similar hardware. Cool. Portia chip pinout. What the hell? Anyway, so what are we doing today? Well, I've got all the code. I want to just go over it briefly. I want to touch my briefs on this just briefly so that we know what I've done, what I've changed. And then I want to get it running on the breadboard because this breadboard will become my keyboard. Obviously, this isn't going to get transplanted inside of the hardware, but what we basically want to do is get all the software running, at least in a fledgling way, on this, and then we can spend time building the actual hardware onto the back of the keyboard. We're trying to vet out whether or not using muxes is fast enough. What's a mux? A mux is a way that you can turn a multi-pin signal into a single-pin signal, or turn a single-pin signal into a multi-pin signal. This is something that comes up in telecom a lot. And it's just a way to switch multiple inputs to one input. And they run fast. You can run them very, very fast because what they can do is they can give you, from your one analog input, you could have 5 analog inputs. It's just you need to allow all the voltage levels to kind of settle out once you switch to that input. The reason that I have so many muxes is because of the way the brain works. The way the brain works is that your brain uses approximately the same amount of blood at all times, and it divvies up the amount of blood going to different portions of the brain depending on what thinking task you're doing. And then it also, that blood gets deoxygenated when it goes to a portion of your brain that's actually using that blood. So to get blood use and blood oxygenation, or blood volume and blood oxygenation, you can use infrared light. You can use near infrared light on the frontal lobe because hair's not in the way. And then those frequencies of light go through guts and blood and stuff well, they bounce off of blood. And so you get a certain amount of illumination. It's that thing where you hold a flashlight on the back of your finger and it lights up, right? There's a certain amount of illumination in the near infrared frequencies that will give you blood flow and oxygenation. How is that relevant? Well, when you have 2 frequencies of LED and a bunch of sensors in a circle around it, and you're doing this in the early 2000s, there's not a lot of analog inputs on stuff. And so you use those muxes to go from analog sensor to analog sensor to analog sensor to analog sensor. And so you can do bop, 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 and you can just read all of them very quickly and figure out what the statuses of a bunch of the analog inputs are. And you don't need 10,000 analog inputs on your device. So I have a lot of Max 308s because I worked on that brain scan project a long time ago. Yeah, so anyway, I have a bunch of Max 308s. They're not ideal because we're muxing digital stuff, not analog stuff. Oh well, it's the parts that I have, right? So what we're doing is we're trying to put QMS on my dead keyboard. My keyboard died, if you guys are that far back in the narrative here. I've spent a little bit of time looking at projects that people have done with the code 10 keyless keyboard and QMS. The grid scheme on this keyboard is wild. It's all over the place. And so I had to do a portion of reverse engineering to figure out what the mesh was going to look like on this thing and convert it into these crazy matrix files. These matrix files just say if row 4 column 7 is active, this is the key, right? That's all they're doing. So I had to I basically, Short Lurker linked me to a QMK. Did I call it QMS again in the title? No, I actually called it the right thing. I found a QMK Short Lurker, friend of the show, linked me to an online tool that actually gives you all the software. It just doesn't support the RP2040, the PicoPi. So what I ended up doing was using that tool in order to make the matrix files. And from there, we've modified the code in QMK. So there's a matrix.c file, and that has a bunch of native functionality to it. We've modified that file based on, well, just the way the muxes are going to work. See, okay, I need to show the, where's paint? I'm like half headache today. All right, let's see. Actually, let's move it over to this screen so I'm not looking at my belly button. There. My thumbnails were heinous for a while because I had the working, like the desktop over there, and so I'd look down at it, and then all my thumbnails were just me looking like this. It's bad. So yeah, having it up here is better. Just means that you guys occasionally see my dashboard. My dashboard. Okay, so these are internal. These 2 resistors are internal. Internal. See, the way the keyboard normally works is you would have rows and columns all going to the microcontroller, and then the microcontroller would activate the row and deactivate the column by going high and low out of the general purpose I/O. We're not doing that. Instead, we have power on the mux. We send the mux an address. Hey, Jeffson, subbing at tier 1 for 4 months. Thank you, Jeff. Is it Jefferson, son of Jeff? Thank you. I appreciate you subbing for a 4-month streak even. Okay, so what we have is just an address, right? You give it the address and then you activate the enable pin. Now, my understanding is we can just keep these enabled. We'll just keep that on because we'll give it the address and it'll just flip that one and then settle out that voltage level. So we'll just put these to 3 volts. I'm doing 3V because I don't feel like doing the decimal point. So 3 volts like that, and then we don't need We don't need to do anything about that, because like enabling and disabling the chip, I mean, maybe that would be useful for like powering down, but the USB bus will be fine with it. So we'll just enable those permanently right now. Permanently enable the 3 chips. They're always going to be, you know, outputting and switching depending on the address. So we just give it this basically binary number, like 0 through 8, and it'll trigger 0 through 8 there. That will switch 3 volts to the rows. When the row is not active, I guess it'll just kind of float, right? So I don't know whether or not we need like a pull down there or what. I mean, when they're not active, they're going to be just floating. I think that's going to be okay. I mean, what you have in the matrix like this is you would have rows and then you have columns, right? And then you have switches between them. So the switch will bridge that line between the two. So if you have this at like 5 volts, and then you're sensing what's going on like here, when you press that button, it's connecting the 5 volts to that column, right? I don't know. That's like a terrible explanation. I could find animations on Google Images much easier to explain all that stuff. There's also a diode there in order to make sure that your flow control is correct, so you don't get like what's called a ghosted button, where if you hit a button or hit 3 buttons, it looks like another button is hit. So we've got diodes on this circuit board already, and the rows and the columns are kind of weirdly organized. Here's how the rows and the columns end up correlating to all the buttons, like O and P and scroll lock and then QWR. It's all over the place. And if you actually looked at like where the grids are, it's weird the way this thing works, because there's like a column that goes here. Okay, wait. Here's one column, 43, 43, 43, 43, and this one too. That's one column. So it would be like that. And then row 35 is here, 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 here. It's like, it's all over the place, right? They just skip around. I mean, the only semblance of order here is towards the center of the board, where they have things like row 36 goes ASDF, but that's all you get. It's all over the place. We'll be able to pick up on the lines we need to and solder to them by just soldering to the buttons themselves. I mean, I might, if I really want to be a fancy boy, I could scrape up the trace and try to utilize something like that. I correlated all of the rows and columns to microcontroller pins, and I put them on a chart, and then I've transcribed the chart. I did a lot of work in this. I don't know if I needed to. On a typical keyboard, you don't, like, if you're wiring your own, you just do it on grid. That's all you need to do. For some reason, Code, or WASD, decided to just go nuts with the rows and the columns. But all right, whatever. Mapped all that out, and it turned out that there were too many pins. If we were to run directly from this microcontroller, from the Pico Pi, there's too many pins. I would take up every single pin on a row and a column. Even if I just isolated the rows, or like if we just ran the mux with the rows, we'd still need 16 column pins. It might not leave enough pins for me to utilize other functions of QMK. So what we've done, what I've decided to do using the Royal We, I am running multiple muxes in order to run, basically activate a row with 3 volts and then scan through the columns to figure out which ones have power on them. And we're going with a positive power scheme instead of connecting ground because of the direction of that diode. That diode, the anode is up going towards the row and the cathode is going towards the column. So I figure in order to activate a row, I give it a positive voltage signal, and that flows this way through the circuit, through the internal through the internal pull down, which we don't know what the value of that is. I could probably just look it up, but through the internal pull down, and it is read by the pin as being a high voltage level. Read at 3 volts. Best stream for me to work to. It's interesting, but I also have no idea what's going on. Not another one of those comments. So it's very enjoyable. I also feel like I missed. I never feel like I missed anything because I wouldn't understand what I missed. Shut up. You shut up. You shut up. I get that comment so much. I don't know what you're talking about, but I like your stream. Well, I appreciate it. I do. I genuinely do. This isn't that complicated. It's not that complicated. It's not that complicated. It's just a button between a row and a column. And we're just scanning through in order to see what button is pressed. That's it. That's all we're doing. It's so simple. It's just a lot of work. So anyway, QMK is pretty complicated in the way that it functions. I mean, they generally assume that you're directly connecting microcontroller pins to your rows and columns. So I've had to do a little bit of work in the code in order to make it basically do what I wanted to do when I wanted to do it. So we are in the NAS, we're in the project, stream projects, keyboard overcall, QMK home, bother board. And what I've done is I've made a zip file of this, well, a RAR file, RAR XD file of this code before we start. I don't have knowledge for the subject, but it's nice to listen while working. I like Bother's voice and narration. Well, thank you. I appreciate that. I should try to get voice acting gigs because I'm that awesome. No, I don't know. Anyway, okay, so the key maps we have, we're using the default key map. The key map, so basically when you scan through a matrix, you're looking at the rows and the columns and you're figuring out which ones are actually pressed. Well, all of that has to actually correlate to something that tells the microcontroller what buttons are pressed, right? VoiceBox has the cool voice. Are you kidding me? I can't compete with that guy. Why can't you be more like VoiceBox? Okay, so this is essentially what the layout of the keyboard should look like, and this is how all the keys lie. It's just all over the fucking place. It's nuts. This key map just tells the software, when I look at a row and a column, what button is being pressed. So if we wire this thing up true to my schematic, then we will be able to get proper button presses from everything. That's all this file does. And there's a way that you can configure this file online. There's a tool. Well, there's a tool behind the camera right now, but the other one is project. I'm gonna scroll up a little bit. I think. Yeah. There's a whole QMK configurator tool that exists online. config.qmk.fm. I don't know why we're looking at this weirdo layout, but yeah, it's just, I mean, you can just choose from pre-made keyboards, or you can get, wire up your own, basically. This isn't the tool that I use, though. Where's the tool that I used? Is that the tool that I don't think it's the tool that I used. Oh, one sec. Let me find the one that was linked like a couple days ago. Because really the hardest part is getting those rows and columns all sorted out. And then, of course, we had to add special stuff to the firmware. Oh, keyboardlayouteditor.com. Or no, what is this one? That's layout editor. KB firmware? Yeah, this is the one. Well, what you can do here is paste the layout. You can make the layout in keyboardlayouteditor.com. And then you can cut and paste, what is it, like the Java? I think you take like the raw data from here and you paste it into there. Whatever, I forget how I did it. It'll make you basically the firmware for your keyboards. You don't really need to screw around with a lot of the stuff that I have, but I work on a lower level. I like my microcontroller code. I used one of the editors to do the rows and the columns of the keyboard, and it ended up looking like this. So you can tell where all the rows and the columns are, right? Yeah, it looks pretty clean. This is how the rows and the columns are organized in the code 10 keyless keyboard. I don't know what drugs they were on, but they must have been very nice. I want to get my hands on some. Oh, I missed a bracket. What does the KC stand for? I don't know. I have no idea. Okay. Anyway, so yeah, that's what that file is. The key map didn't actually end up getting axed with everything else. So it's nice. It's nice that this one is here. Okay, the next one that I did was... So this folder basically contains all of the overrides in the software. When you compile QMK, it has kind of like a default mode that it wants to get into. It needs the information that you're pasting in here. The reason that we have so many files is because I actually have like extra files as like a driver for the muxes, so that the code is just a little bit more legible. We don't have pins getting triggered on that on our main matrix file. There's also the botherboard files and a configuration. Info.json, we're pretty sure that's pointless. Like, the software doesn't necessarily use that. Matrix.c is basically matrix.c is functions that QMK uses to read the matrix. Typically, this wouldn't be that complicated. It would be activate pin, read rows, or activate row, read pins. You see, it could be any facsimile of that. QMK is so universal that the code for it is downright illegible, because you will be looking at functions in files that define functions in files that define functions in files. You dig down deep, and then you find out that this giant keyword that you were looking for, and this happened yesterday, you had this giant keyword, like this variable that was named here, is just a 1. It's just the number 1. It's the one that I'm talking about is matrix row shifter. The variable matrix row shifters. Ooh, what is that? That's like a weird special variable. I don't know what that's doing. It's probably doing something really, really cool and interesting. No, it's the number 1. It was just the number 1. so anyway, that would be the matrix row shifter variable. But the whole thing is like that. It's just super convoluted because there's so many different bits of hardware that this thing exists on. We don't have such weaknesses. We can run this on whatever, and we are running it on our specific piece of hardware. Okay, botherboard.c just says include botherboard.h. All right, that's a great function. So this is another one of the bastardizations of the rows and the columns of the key map. I don't know why there are multiple files that define the key map, if this is like an override or what, but I don't know. This is just where they end up in the matrix. And so the key, basically when it sees a key's pressed in its key press matrix, it'll reference whatever this is, and that'll activate the button, via USB. So that's what botherboard.h is. And that file, I think, was generated by the other software, the online software. That's what that is. So config, now we're getting into it. Config is where all of your stuff should be, all of the actual like pin numbers and the process. It didn't define the processor here, did it? But we're basing this on the code that ran the screen, so hopefully everything's okay. But yeah, config common, pragma once, all that stuff's in there. Then we get into the actual stuff. So vendor ID for some reason is feed. There are specific USB like IDs that people should use for stuff, but we're kind of free when we get to the device version and product. So obviously I put that number in, and then it's keyboard. Matrix size, those are used in various places of the software. We did a nice clean 8x16, which means that there's an extra pin. But I don't need to put ground on this pin because it's already going to be pulled low by the internal resistor. So this can just float. This is just a dead end. Basically, when I organized all this stuff, basically, there's 18 columns in this thing. 18 columns make up this keyboard, and 8 rows. Conveniently 8. I mean, that makes sense, right? I don't know why there's 18. Maybe because the 10 keyless, maybe because there aren't the keys over there. Maybe there aren't 10 keys over to the right. That's probably why some of this stuff is a little bit weird. But anyway, 18 I was able to turn into 15 by taking this block of buttons and just moving it over into different rows. So instead we have 16 inputs to this thing. But 15 inputs. 15 is not an exactly divisible number by 2 8-pin muxes. So what we have is just a dead pin. What I've had to do is define the matrix as being 8x16. So what'll happen is every single cycle we will be scanning a column that doesn't exist. But that's not going to really slow us down, because we would have to do that anyway. We're kind of stuck doing that anyway, because both of these muxes are going to work in tandem. They share all of their address pins. So when we ask for an address, we get the column, and then we get the column plus 8, whatever column number and column number plus 8. That halves the time it takes to scan them. So hopefully all of the scanning methodology that I'm doing here doesn't severely limit the capability of the keyboard. We may need to put a big delay on this thing because I think it takes 30 microseconds for this thing to settle. Presumably that's not going to be an issue. We'll have to see. I know that split keyboards run I2C, which is integrated circuit communication. Basically, you have SDA and SCL. That's these two lines right here. And they would be communicating with something serially instead of in parallel. And serially means that you would have to give a voltage level, basically like a coded signal from one thing to the other based on the clock that was running around. And that's going to tell it how many of the split, 515 buttons are pressed. That means, and the linearity of, not linearity, the fact that it's not parallel in any way is slower because it takes time. That clock pulse takes time to go from thing to thing. Apparently people with split keyboards, they don't notice it at all. The speed of the human in this equation is extraordinarily slow. People are slow. And so hopefully we won't see any delay when we get these muxes up and chooching away. We get them up and screaming. That's the only piece of information that's comforting me throughout all this work. Anyway, okay, so yeah, we define the rows in the column. Uh-oh, don't move your code. We define the rows in the columns, and then I give them pins, even though I don't really think I need to. The software looks for them. The QMK compiler looks at the number of rows and columns and makes sure that everything matches up. It actually yelled at me for having a different number of matrix columns versus matrix columns pins. So instead of actually just not having this information here, we have to define it as no pin. We have to actually call it out as no pin. And then for the columns, I just did GP2 and GP3. In our matrix code, we're just going to directly reference position 0 and 1 for this variable. I don't know if I need to, do I need to move that into something? Oh, you know what? It moves it into something in the actual code. Never mind. Okay, so then I have some stuff that I wrote custom based on other multiplexer code that exists within the QMK project. But like the QMK project, man, the way some people code is just ridiculous. Like they insisted on iterating through the number of address pins instead of just directly defining them like I am here. Like why? Why would you do that? I'm just directly defining the pins individually, right? In their code, they wanted to have an array of pins and then go through it iteratively with a for loop. And it's like, why? Earlier message went through for the phone app. Yeah, you said hi twice, I think. And then the Twitch app complaint. They insist on having arrays of pins, I guess, and that's just in case you want to use like a different thing and you want to cater the code to that different thing. But it's so stupid. Like you're using a specific chip. Still loading stream on the phone. I've tried to use the Twitch app. Yeah, it's generally very frustrating. Anyway, so I simplified the code quite a bit because, I mean, we're talking about very specific hardware in a very specific application. I get to do this. I don't have to make the code as universal as other projects using this code are. So instead of having like an array that we iterate through, I'm just straight up defining the pins. And at the moment, we don't have any of the enable pins on here. We can cater this code to do that if we need to. The OLED code is from something else, so I put that in there. Diode direction, row to column. I don't know what this triggers or does. I don't have any of the clauses in there to specify row to column. It may be part of like the other code that I don't know about that QMK is running. And then there's some stuff in here about backlight pins. I don't know what that's doing specifically. Debounce, I'm setting that to 0 right now. I don't know if we need it or not. We'll find out if we're double and triple pressing keys. I would like to get there. Lock key support, of course, we've got caps lock and stuff. Locking resync is just something that also exists in there. So you can see I've simplified the code quite a bit. I'm trying to pare it down so that it makes more sense. Config H, info JSON, we don't care about. Matrix.c. This is where the magic happens. Matrix.c. This is the C code that runs the matrix, and I transcribed all this stuff from the old one. I rearranged it a little bit to make more sense, too. So we're using my Max 308 driver. I guess quantum has to be in there for some reason. Matrix.h is the original code, so anything that we didn't cover in this, for instance, like how the main loop is running and stuff like that, that would be in matrix.h. So that's why we reference it. Standard booleans and standard inits, because we're doing a lot of stuff with inits, or sorry, standard int init, standard integers. So we got integers and booleans there that we've imported. Hopefully that works. Static constant. So this is our array of pins. I don't know why we're doing it this way. I don't need to do it this way. I could just load, well, I guess I'm doing it this way because the matrix column pins are represented as an array. I don't like it, but I'll just keep it. So when we initialize, so by the way, I rearranged this code and I got rid of a lot of the stupid functions that were in it. When you see stuff like this and you've got a static function in here, it means that the static function just exists inside of this file. So basically what they had in this file was the matrix scan custom, which is what the main program is calling, and then they had a bunch of other helper functions that they wrote in this file specifically to do the work that they needed it to do, but it was too convoluted. It was confusing and annoying to have all these weird functions inside of this code. It doesn't need to be here. So I've simplified it quite a bit. Max 308 row init and column init. What that does is that just sets the pins that are specified here, these guys, in the driver. It specifies these pins and then defines them as outputs for the microcontroller. And then as long as there are pins in the pin matrix, it will set them to an input low, which means it activates a resistor to ground so that when you put a positive voltage signal on it, it'll show that positive voltage signal. When you take it away, it goes back down to 0. And that's the trick. There was a bunch of code in this file that was dependent on the rows being activated by the microcontroller. And so what they were very careful to do was have a row deactivation where the microcontroller would set the voltage level to 0 afterwards. And then they have all of this code for like settling time and making sure that everything's settled. We don't have the luxury of being able to check all of our columns inherently, right? We can't wait for that to settle. So what we'll do is we'll just put delays in there as we see necessary if that becomes an issue. I don't think it will be, but I don't know. We'll see. So anyway, activate the row, scan the column into the row matrix containing the binary key press values, right? So we got two tasks here. We need to activate the row, and then we need to iterate through the column and populate that into a variable that gets put into a matrix that represents the keys that are pressed. So first of all, and for some reason this is a Boolean. I don't know what the main software is doing with that Boolean. I'll just do what the other person did and keep that. So if the keys change, we need to have that Boolean return as true. So we started off as false. We assume that nothing has changed first. For our row equal to 0 until we get to the max number of rows, we iterate through the rows. And so when we iterate through the rows, we call max 308 set row address. And so that in my driver file will basically just take the pins. It'll take the binary number as it's stored in a UNT, and it'll turn it into ones and zeros on the pins. I looked up pin registers on the Raspberry Pi Pico to see if it could be done like instantly. I could put that code in there, but it might overcomplicate it a little bit. So I'm just, we'll look at the driver file in a minute. But anyway, so first we set the row address, then we read the columns on the row, and that's the function down here. See, I rearranged these functions, so they actually make sense now. How weird is that? So the main function is the one that's called by the main code, and then this is a function that I made in order to read the columns on the row using the max 308s. So this Boolean is just, if read columns on row ever returns a true, then this remains true. So if if the row, sorry, if the columns change, that Boolean will propagate back to the return and then be returned by this function. It's a weird thing that it does. But yeah, read columns on row, we pass the current matrix into it, and then we tell it what row we're scanning at the moment. So then this function walks so that this function can run. This one, we do the same thing. We start with a false variable, and if anything ever changes with it, we'll set it to be true, and that's what this does down here. It's the last thing that it does. It scans the column, both columns, and then it checks to see whether or not any of this stuff has changed. So this goes column by column, and it'll scan all of them, but it'll do it in parallel for 2 of the columns. So what we're doing is we store the row. We store all the values of the row into a variable, and then we come down here and we do our loop. And so our loop is just going to run through 0 to 8, and we fixed that value. That value is not, you know, number of rows from the from the config file. It's fixed because we've fixed hardware. We've fixed special hardware on this, and it's not going to scale to other projects. I had to reboot the phone to make it work. I had to do that with Discord lately. It's been kind of glitching out on me. All right, so anyway, we're going through column by column and reading twice. So there's a little bit of a redundancy here with this code specifically, where it handles that the values in that matrix, it's writing one and then it's writing the other. It's just, I don't know, whatever. It's fine. It's fine. So we set the column address based on the index 0 to 8, and that's going to set both of our muxes, and then we give it a little bit of a delay, and that should hopefully let things settle down to the point where we can get a good read on that digital input, on the GPIO input. So we check the first max 308, and we read column pin 0. This should be 1. And there's a lot of little mistakes like that might be in my code. I got to be careful about that because all this stuff is transcribed. Control S. Yeah, so we read the fixed column pin, right? And so we can reference it in this table, and that's just going to be what we put in the settings file, and that represents the 2 GP2 and GP3 that we are reading from. Okay, so that's if it's a positive pin. So if that's positive, if we were looking for a 0, I could just do an exclamation point in front of it. If not, read pins. But we're doing a positive activation, so that means that the position of the matrix at that row, what is it? Oh God! So that row is just a bunch of, it's like 16 binary values, and what we're doing is we're setting it to a 1 by shifting a 1 the number of positions over that the column is. And then this matrix row shifter is just number 1. That's all it is. Conversely, if it is a 0, we're using an and equals of a not of the 1 turning into a 0. It's really weird. But then we're shifting it over, obviously, to be in the right position. So that's how that works. And so the next one, the second read, all we have to do is just add +8 to it. It's just 8 pins over, right? That's it. So it's 8 positions over in the matrix, but it's getting read at the same time. So we come down, I mean, virtually the same time. This will take like a couple microseconds to do all the instructions. And we come down here and we do this one, right after it. So column pins of 0 and 1, those are fixed, et cetera, et cetera, et cetera. After we're done scanning 0 to 8, we have all the positions of the keys in that little snippet of time. And so we take that and we see if anything has changed. And if it has, we set the variable to true. Otherwise, it's just false. And we're done. We can return the matrix changed. And that'll tell the software, I guess, that stuff has happened. Now, there's no other functions in here. We're done. Only 75 lines of code because I pared it down. I cut the fat. There was a matrix initialize custom, right? This would get called, and then it would run another function before it got to this loop. It's so convoluted. It's stupid. But anyway, the max 308 code is fairly simple. I'll just show you guys that. I want to show all this stuff in case I accidentally delete the whole thing again. We include the H file. We include GPIO because we're going to be directly referencing the pins that need to be pressed. I don't know if I need to include GPIO in this one. I don't think so because we're not referencing directly GPIO. We are using, yeah, we're using a function. Set pin input low. I don't know. We might have to call it. We might have to call it in this file. We might have to call GPIO. Set input low. Yeah, we might need it in there. I don't know. I don't know yet. We'll see what the deluge of errors that we're going to get from the compiler. All right, so first thing that I do in this is I just check to see if the row A0 and the column A0 are set. It probably should be like A2. Yeah, we'll do A2 because that means you're not using a max 308. So if you don't have in the config file these calls, and I'm not going to write a check for every single individual one. I don't want, it's just a mess. So I just check to see if one of them is set, and if one of them isn't set, I'm going to assume the worst and say no column address pins defined. Oh my God, he's not using the software that I use. Oh no. Okay. So when we initialize our max 308s, the initialization is just basically making sure that the microcontroller knows that it's an output pin and to write the pin as low. So these are all the addressing pins for the max 308. Now, I didn't do anything with the enable pin because I'm trying to keep it simple right now, right? And we're directly addressing each of these pins instead of running a loop through a freaking like matrix of pin numbers. It was so weird that they did that. I don't know. These programmers, they're so insistent on doing things in a certain way that it ruins the simplicity of the code, and it makes it much harder for dumb people like me to figure it out. My simulation finally gave reasonable results. Oh my God. That's right, you didn't do a hello world. You jumped right into it because it's client-based. Oh my God. 3 weeks on a simulation, you finally got it to do something. That sounds like a high-level simulation thing. Anyway, we've got 3 chips, but 2 of them are basically in parallel to one another. So we only have to do the same thing for the column pins. We only have 3 column pins and 3 row pins. So what I'm doing is I'm taking those definitions, setting them as an output, and then writing them low and ready to go after that. We're on 0, 0. Yeah, congratulations on getting that to run. So then the same thing. This code in the driver for the other there's like another mux that they have code for, and they've got a driver written, and it's sloppy. It's really sloppy the way it's written. It's written as if you would someday be getting a mux that has an extra pin on it. Ooh, what's that doing there? Like, it's written specifically for the hardware to make it specific for the hardware. Anyway, so what I'm doing is I'm writing to the pins the address, and I'm shifting the address over using the number 1. I'm just shifting a 1 over to the address location. Should I be using the number 1? I think that should be the address. Wait a minute. How do we address this? Hold on one sec. Oh, address and. Yeah, okay. We're using the 1 as a mask, I guess. We're anding it with whatever the mask is that we make. How's that work? Oh, 1 and 1 is equal to 1. 1 and 0 is equal to 0. Okay, that's how we're doing it. Is the hardware work done on the board? No, we're trying to do software so that we can do hardware. Yeah. Our code looks like this so that our hardware can look like this. I want to do the hardware because it's cooler. It's more fun to do soldering on Fridays. I'm just going over the software right now just to show you guys what we're about to fucking wrestle into this microcontroller. So on the H file's simple. It's literally just the functions of the thing. I did not set anything to do with the enable pins yet. If I need to, I'll know how to put the code in there, but I'm trying to keep it simple. So MCU conf configures the microcontroller, and it tells the software what we're doing with it. This is basically directly off of the tutorial that Adafruit has for running the screen. And so that's all there is in here. Include mcuconf.h and do this stuff. I don't know why. What does include next? hold on. Include next. What does that do? Wrapper header. Adjust the contents of a system provided header file without editing directly. GCC's fix includes operation does this. For example, one way to do that would be create a new header file with the same name and insert it in the search. I'm not reading that right now. I don't even know what any of that means. Okay. I don't know what any of that means. I should just be playing games on Twitch instead of this shit. This complicated bullshit that I have to do. I don't want to do that. I just want to play Noita all day. The readme MD, I don't care. Rules.mk. This is the last functional file in there. All it does is it creates a bunch of little things that get set or unset. I kind of rewrote this because I didn't like the original one. I just kind of did it my way. But if we need to enable other features, we can do it in here, in the rules. So, okay, so that's everything, right? Let's see if we can get this thing to frickin' compile, right? Oh my God. Well, this is what we had before. Okay, very careful operation here. This is where the rubber meets the road. I need to make sure. Let's get rid of shadow copy folder. I need to make sure that I don't cut and paste this thing from the wrong location. So we're in the file server, we're in the NAS, in my projects folder, in the stream folder, in the keyboard overhaul folder, in the QMK folder, home folder, and the botherboard folder within that. Now I've already backed it up. That one little correction to the pin thing is not in there, is not in that RAR, but whatever. So I'm gonna take this, I'm gonna copy, very carefully, copy, and now I wanna go to the folder on my desktop because I use a file server and QMK does not like referencing file server locations. So this is annoying, but I have to have a local C file, C disk file at the default location, which is users, bother, firmware, keyboards, and then botherboard. And so now, highlight this, delete it. I'm very, very carefully doing this, and then paste. Okay, there it is. It's all in the right location. Now, the stuff the compiler will yell at me for is in reference to this. I don't know what direction I want to update these files in. I gotta just make sure that I keep these folders in the right spots. Don't magically shuffle them around so that it bites me in the butt. QMK flash. This is the command that we're gonna be running. It's from the default folder, so the folder we just put all the files into. Keyboard is botherboard, and the key map is default. So we know that all those files are ready to go. Let's do it. It's gonna be something stupid, right? I probably forgot a semicolon on the line. It's thinking. Here we go. Here we go. Matrix pins are specified in JSON and config. Config values win. Making botherboard with key map default and target flash. What the heck? I got a folder in the way. Critical error. Hey, no, no. This is from yesterday. This is from before I deleted all my files yesterday. Hey, this is my cousin here. Yesterday we were about to flash the software onto the keyboard thing, and I had a cut and paste just mega screw up, and I ended up deleting all of my files. So I had to go through my VOD and watch it and actually look at all the screens that were up there and then transcribe all of the code. Why is it not doing anything right now? What is it doing? I spent a lot of time last night not hanging out with the corgi puppy and instead writing firmware. Ugh. I should have probably given it more jobs to run with, right? What is happening here? This has been a lot of work to resuscitate my keyboard. I'm surprised nobody's done anything with muxes like I have. Making projects on projects. Yeah, it gets a little fractal sometimes. Doot. Waiting for something to happen. Nothing is happening. This is a lot faster yesterday. What's happening here? What's going on? You didn't know? Oh my god. Oh my god. Here, I gotta show off the corgi puppy. Hey, show off the corgi puppy. How long should it take? It took a long time the first time, so it may take a minute. It may take a minute. Hey, Corgi puppy, your name is Willow. Her name's Willow. Look at her. She's so cute. She has these droopy ears. She's about 12 weeks old. Okay, stuff is happening. Good. 12 weeks old. She's a cutie. Cutie little patootie. She's very bitey right now, but she'll lose those puppy colors and have longer hair because she's a fluffy corgi. And then her ears have only started to like perk up. So as she grows up, her ears are going to perk up a little bit more. But yeah, she's super cute. Super duper cute. At some point, I will have her on camera, but she can't really be down here yet. She's too much puppy energy and a little too chew on everything energy at the moment. There's too much stuff down here that would get in the way. Oh no! Undetermined if and def. I don't know what that's even doing. If and def config H. And just get rid of it? I don't know what it's doing. So that one is in, I believe. That's up here. Needs the closing statement. Oh, make sure that stuff isn't... Add endif config H at the end. Okay. Oh, okay, so that's what that's doing. This is saying if config H is not defined or whatever. It's just trying to... So that needs to be there. You're just a tiny mistake. Call me a tiny mistake. Says, oh, your mistake's not that big. Fuck you. No, I'm just kidding. It's like missing a semicolon. Yeah, I'm not too familiar about the defines and stuff like that, how all that stuff works. So I think that does it. After all that, one semicolon. After all that, just one semicolon. I have it open twice. Why did it let me do that? Oh, because I'm editing the one on the C drive right now. All right, let me close these all. We'll copy the code back over to the file server once we're done here. Preprocessor directives. Well, bop, bop. You have my semi-condolences. All right, we're back to that. Let's look at cute puppy pictures. I don't have cute puppy videos. I've been doing that. But yeah, she is an adorable. That's what she is. She is an adorable. We've learned the come command in order to not run away. And that's about it. I've been trying to teach her. She knows sit, and I've been trying to teach her shake, but she doesn't exactly understand shake at the moment. She likes to lie on her back in bed or on the fireplace slab. She's a very cute little puppy. But it's been kind of like, it's been kind of hell. No, don't be a weirdo. Yeah, it's been puppy hell. Trying to get sleep and have a puppy at the same time is not exactly happening. So she does sleep through the night though, typically. She gets up to some mischief though. All right, let's see. She'll like dig in the crate. We're doing crate at night for now, until she gets a little older. Bum, bum, bum. Another error. Wait, it's the same error. Extra tokens at the end of the endif. Endif. Oh, I just need endif. I don't need to specify config H. Your cousin is a natural on Twitch. Yeah. I'm not proud of it. Let's see. We need to go to the C drive. Make sure we're in the C drive. We're editing this one. And we don't need this. We just endif at the end. Okay, try that. Compile. All the same warnings. Warnings are fine. Careful. Careful. I have a mega headache. Mega super duper headache. I'm trying to hydrate it away. It exploded. Okay, so we still have stuff going on here. Unknown type macro T. Constant macro action get macro key record T. What the fuck? Macro none. Undeclared. Return macro none. What the fuck? Where is this? In keymap.c. Unknown type. Constant uint 16t. Keymap. Rows and columns. Oh. Maybe I need to include... Do I need to include int or something like that? Yeah, I think I forgot like an include in there or something. Oh no, never mind. We're down here. Okay. Get macro, key record, macro opt, key event, key record event, switch ID, macro none, matrix init user, matrix scan user. I am wondering if I need to just delete a lot of this stuff. Let's look at what the Adafruit code had in it. Because it had stuff going on for that. Did you copy that from a keyboard that uses AVR? Yeah. This should be C++-ish. But yeah, I think this must have been from an AVR project. So I don't think I need to do this. Yeah, let me just, let me get their code. Where is their code? Where's your code? Show me this code. Oh, wait, it's already in the project. That's right. What did they choose? They chose... It's like in the Adafruit section of the project already, right? B develop? No, that's not it. 2040 reprogrammable, reset buttons available, double click it. Once your computers recognize the RP, blah, 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 blah. Initiate the build and upload Arduino or QMK Flash. Ready to get down to business, buy our stuff. Where's the next part of the... Maybe this was it. No, we wanted the screen on there. What did we run? We ran something that was like a whole... It had the screen on it and did a bunch of stuff. It had a bunch of like macros for the screen that we could test. Maybe it's in the official instructions. That might be it. CLI, using QMK. C-based languages. Yeah, it's... I mean, it's not like I wanted to learn any of this stuff. I wanted to do stuff. No, it's not the thing from Short Lurker. I'm looking at the original tutorial that we followed in order to get the OLED screen working, because I just deleted all the files. So there was some kind of a tutorial or something that we followed that had all of those functions for like the screen testing stuff. That was based on like running it into a button. If I don't need, I mean, okay, so do I need any of this stuff? Like, I don't think I need this. I don't think I need the init user, scan user. Like, I don't know why I'd wanna overwrite those. Process record user. I don't need any of this stuff. And that's LED stuff, and we haven't baked that in yet. So maybe we could just get rid of all this stuff. We could just delete it. I never knew what this stuff was doing anyway. Is that needed? Well, that's got a semicolon after it. Yeah, I think that one is needed. Because progmem, constant uint816, key map, boom. And then that correlates to that one. and then it has a semicolon after it. So I don't need this. Maybe. Maybe. Let's save it and just try to compile it and see what happens. Oh my god, it got really angry at us for that one. When unsure, delete. Miguel Oz! 30 months! Miguel Oz, thank you so much for subbing. I appreciate that greatly. Alright, alright, alright. We're waiting. We're waiting. Still waiting. Target flash. I think that might be a good sign. Okay, 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 alright, okay, alright, okay, 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 yeah, okay, 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 okay. There's a lot of okays. There's a lot of stuff is alright. It's quite a few actually. It's getting kind of, hey, it's getting kind of a little crazy. What is all this stuff that you're doing? Why are you doing this much? I edited like 5 files. This is like 60. This is like 60 files that you're importing. What are you doing? Hello? Help? Help! What is it doing? Hey, are we still doing this? I think it's gotten past my files, so I think my files are okay. It has become sentient. Oh my god. What are we gonna do? What could possibly happen now? Okay, this is a lot. Hey, QMK, I think your project is a little bloated. I think you might have a little bit of a bloat issue here. We only need 7 gigs of space in order to make a keyboard. You what? Like, keyboards aren't that complicated. Oh my god, Ducart, thank you. Thank you for subbing. 14 months. Have a great stream. Hope the keyboard gets fixed. Yeah, go to bed. This is on Australian time. What are you doing here? I appreciate it, man. I appreciate you popping in to catch up. Yeah, all this is necessary so that I can push a button and it can activate a key on a keyboard. We need all this. This is a lot for just a keyboard. What is this? It's like, do I need all this? I don't think I do. RP2 common, that makes sense. Jesus Christ. Okay, so let's plug in the micro. I don't know if the screen's gonna do anything when we power this thing on. I think I need to like, oh no, I need to plug it in with a, well, I can double click the reset button. Hello? Okay, hold on, I need to hold down the button, plug it in. There it is. Okay. Now, presumably, this thing should be running like a keyboard. I don't know though. Unplug it, plug it back in. Well, the screen doesn't have any instructions at the moment because we got rid of the screen instructions. So I think what I'm gonna have to do is probably hook up the oscilloscope to see if it's actually even trying to get anything from the muxes, which it should be doing. And if it is, we can then test a button or two. I specifically want to test 2 buttons. NPS Stewart, thank you for subbing. Appreciate ya. How long is that? 37 months? That's a lot of months. A lot of months. All right, so let's see if it is trying to get button presses. Yeah, MPS Stewart, thank you very much. Thank you, thank you. You're very kind. Did it pop up as a keyboard on the PC? I don't think it has yet. I'm not sure. I didn't look yet. I want to get the probe out for the oscope anyway, so you can get a little bit more data. And then since we're running our breadboard with the ground in the right place, what the hell is this thing? That's not the right thing. What the hell? Who's been using my stuff? Oh yeah, it's just me. Where are my pins? Where are my pins? They're there. Just get one out here for ground. That's not the right thing at all. There we go. Cool. All right, one out there for ground. Oh, I need to get another one for the probe pin too. For some reason, we were doing something in the opposite way we were before, but whatever. QMK toolbox will help you. Okay. I'll have to look that up. I shall have to look that up. I'm getting pins out here. Getting pins out. Pins out. All right, so ground. Get the clearly that was a beard hair. We just look at some of these outputs to see if anything is happening on them. Frickin' nothing. And we're not getting any kind of stuff going on them. The outputs are not activating. That's at 3 volts. That positive there is at 3 volts. We're looking at the address pins or anything. Looking for any activity on them. Let me deactivate the other channels. And then channel 1, coupling DC, bandwidth limit off, probe 1x, invert off, and then we are at 5 volts per div. Back out in time a little bit here. Well, actually, I want to go to a lower time grade. I'll make it a 1 volt per div. There's just nothing going on there. We should be seeing blah, 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 blah. Fixing your flare, yeah. That Robot's crying emote. That Bill emote, I get so much mileage out of that one. I never thought I would, because the original Bill was great, because it was just Psycho Bill. Psycho Kerbal Bill. F. Nothing happening. Nothing doing. Reset. Now, no behavior from the circuit. It could be that I didn't declare something where I needed to, like, for instance, the GPIO. But, I mean, we're not seeing anything on the screen either, so there's some setup that I need to do with that. I just don't, it's just not, it keeps defaulting me to listening with audio on some channels. It thinks you're blind. You son of a bitch. Why doesn't this thing work at all? Hardware-wise, this is the same thing. And we saw, I don't know if you guys saw it, but I saw the screen displaying QMK firmware on it. So I know that that hardware is all set up and ready to go. The muxing, I should be seeing something being attempted by this thing, and it's just not, it's not running anything. So we get to look at what the hell's going on here, I guess. I mean, the code loaded and everything, right? So I think what we need to do is roll back into running some screen code on this thing, so it actually puts something onto the screen. I lost that other code during that cut-paste shenanigans, right? So I don't know what's happening with some of these files. And maybe we need to do the troubleshooter. Let me move my video window over. Okay, so key map aside, it's not even attempting to scan. Whatever is happening with the pinouts, I mean, what do we need? Config common.h, pragma once. I don't know if we need pragma once in all these files or what. It seems like, I mean, we should see something from the matrix, right? So int bool matrix, I wonder if I need IO in here. And we also have quantum H included, but we don't have pragma once on there. I don't know what that's, I actually don't know what the fuck pragma once is doing. Pragma once. Non-standard but widely supported processor directive designed to cause the current source file to be included only once in a single compilation. Thus, pragma once serves the same purpose as included guards with the special. Okay, so if that file exists anywhere else, it's not included. So when we pragma once, like on config H, we're only running this config H. There's also config common. I don't know what the hell a lot of this code is doing. You know, we've defined our pins in such a way that it was successful in running the screen before, so we know that the pin declarations in here are okay. But the thing is, like, where is the OLED being run from? I want to find that example code that we did before with the OLED test. And I think maybe it might be in, this is the stream folder. Let me take all of, well, until we get it working, I guess the stream folder will just go to the side. And let me go to the C folder. So this is where we're working out of. And then I want to open a new window there. So this is where we're working out of. Here, I want to look at Adafruit. Oh my God, there's so much here. This is in keyboards, yeah. So Adafruit is somewhere on here, right? I thought. Some AD. We're in the V's. That's way too far down. ADA. Oh no, Adafruit. There we go. Oh, they only have code for their macro pad, huh? Define macro pad H, RGB matrix enabled. They're not importing anything else. And then they've just got rows and columns in there. If encoder is available, bool encoder update keyboard clockwise. So is this what I need to? I think maybe we're not. I think maybe we're not running the code. Like it's just not going. For instance, like if we open up botherboard.c, it just says include botherboard H. Botherboard H just has this. I don't know. Yeah, okay. So where I thought it was an Adafruit tutorial that we followed. I'd like to go back to that. Or it might have been out of here. So there, let's see, on the left there's all this stuff. And we've got Raspberry Pi 2040 development. I'm looking for the here we go. OLED driver. Usage. If def OLED enable. So OLED driver has to be where? OLED enable, yes. Okay, so to enable the OLED feature, 2 steps. First, when compiling your keyboard, you need to have the following to your rules.mk. OLED enable is equal to yes. So let's take a look at the rules.mark. Local disk C, here we go. Rules MK, edit that. And we need OLED enables equal to yes. Save. Then, where does that go? Is that in config? Usage. OLED enable, yes. OLED type. E.g. that. So I guess maybe I need to do like that. Well, it looks like they're doing some tree work here, so there might be a bit of noise in the background. In your keymap C file, implement the OLED task call. This in your OLED task call. This example assumes your keymap has 3 layers named QWERTY, FN, and ADG. Oh, I don't. We're just doing the logo example. So this would be in the keymap.c. Which I don't have open. Go to here. Go to the drive. Go to keymaps. Default is what we're using. Edit that one. And then at the bottom, add that. Static void render logo. Huh. That's a static. What's calling it? That's a weird one. Progmem QMK logo. OLED write P. Oh, that's what. So I guess this gets run, and then this runs the whatever that writes that as. There was a whole suite of like tests that we ran. I don't know what happened to that code. Default font files located there. Buffer read example. For some purpose, you may need to read this current state of an OLED display buffer. I don't. Other examples. Split keyboards, very common to blah, 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 blah. Okay, blah, 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 blah. 90-degree rotation, technical mumbo jumbo, OLED API. So there's all the functions. Driver conversion guide. Scrolling rotation or unsupported. Yeah, I had like a comprehensive like OLED like thing that I had running. It was pretty cool. I don't know what's up with that. What did the old key map have in it? That might have had something in it. Yeah, there it is. There it is. There's my boy. If def OLED enable. Let's just move that over to the other file. Although we don't have confirmation of a key being pressed, which is what this thing relies on. So I guess what I'll do, I'll just comment this one out, and we'll enable logo. So /star, and then /, and then we can enable this one. Oh, we have basically the same code that we had before, only it's captured in an endif, if def endif. Okay, so save that. That's good to go. That'll at least light up the OLED display so that we can see that stuff is actually happening inside the microcontroller. So that was that. Why is nothing else happening? Well, the great question. I have no idea. We're gonna need to learn how to troubleshoot this thing in short order. So let's get the new stuff compiled. We literally added like 4 lines of code, but whatever, we'll do it. Jobs equal to 1. Oh my god. We'll take little chips away at this thing because this is kind of a lot of code writing that went into this. Yes, yes, yes. Oh no. Render logo defined but not used. Static void render logo. All warnings treated as errors. It's fine. Render logo is not used. Defined but not being used. Yeah, why is it a static? Where do we actually call this function from? How does the other one work? Wait a minute. The other one was just a cut paste job, wasn't it? C users oh bother QMK firmware keymap.c. That's the oh bother one. This is the default one. I want to open the default one, and then I want to file. I want to open the bother one. See what's happening here. Constant unit 16T progmem keybab include QMK keyboard H. I don't know why bother board is being included in here then. And include QMK keyboard.h. Why is that? Wait a minute. Wait a minute, what's going on here? If defined OLED enable static void test characters. This one is static void render logo, and they were saying it's not doing anything. The compiler is being overly strict. They don't want to introduce bloat. My brother in cripes. Look at all the bloat that this fucking software has. Any major fuck ups today? No. 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 Why are you rejecting my static void? My static void cat. OLED right P. What did we do when we got that screen test working? I think it was this one. The test. No, it wasn't the test characters. There was code that I wrote that I had that ran like 50 like screen tests, and it was awesome. But then I also have one that did just the QMK logo. I gotta find that. OLED driver, OLED enable. We did all that stuff. We need to find like a different RP2040. OLED rotation. So these are not statics. Why are these statics? Let's do a RP2040 QMK OLED. Adafruit again. I think because this is the tutorial that we followed right there. I think maybe we just need to find where it is. Because this is the install, and then we're done with that. And we move on to the next one. One key keyboard. Micropad with QMK. Is that what we're supposed to do? Yeah, that's the one. Okay, this is the one. QMK Adafruit Micropad. Oh, that's already compiled. Fuck that. Plug in your macro pad, pressing down on the encoder knob. Wait, pressing down on the encoder knob? This is a totally different piece of hardware. Next. Gherkin. I remember Gherkin. I remember jerking the gherkin. Editing a key map. That's all well and good. There we go. Now to the tutorial. It's like 5 pages later. Oh my god, there's like a big hullabaloo outside. There's multiple saws and trucks. I hear it all. Okay, so pull requests provide easy to use example with the KB2040. I don't want the pre-compiled shit. I would like to take a look at these. Okay. I2C driver, I2D1, we got that. That's already in the files. I know that's there. Following settings are needed in the appropriate MCU config file. We did this, yes. Your board is different pinouts determined, blah, 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 blah. What do we got? OLED enabled, yes, this, and then I don't know what the hell that is, but I guess we're including that too. That way also, we need to put that in there. It says ops deaths plus equals negative doll use I2C is equal to, what the hell? Okay, whatever. Control S. What did I just save over? C users, QMK for keyword, blah, 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 blah. C, okay, stuff in the C file is the working stuff. All right. Function OLED task user contains, oh, I see. So they're actually explaining themselves. Contains code to actually draw the screen in the OLED example. This is the file keywords OLED keymap C. The code can draw letters or work by individual pixels. For more info, check the documentation on QMK's website. This is how they're doing it. Void test characters. This is the code that I put in the top of this thing. That would be test characters. That's this. This is the other key map, right? Keymap dot. Yeah, that's one in the bother folder. So, I mean, technically I could enable this one. I don't know why it wouldn't run documentation on QMK's website. That's the same thing. Compiler option that sets the HAL underscore defined to true somewhere in the QMK firmware. Oh my god. Oh my god. I don't understand what's not happening here. Because we've got the OLED sitting here like this, and technically this should just work. I don't know what's running it. If does the function just like run once at boot or something like that? And then the Adafruit thing has me doing that weird thing. Columns, rows, blah blah blah. I feel like it's like something wrong up here that's happening. Like the stuff that I'm declaring isn't working properly. We're trying to get to where we were yesterday with the screen working and all of my crazy go nuts code in there. Well, let me save. I don't think I really changed much except in the header of this file. So let's try that now. Yes, waiting. Now we wait. Now we get to wait. My glucose level's through the roof. I need to make sure that I'm okay. It's getting back down there. That's good. Because when your glucose level's high, you gotta pee a lot. So you step through the code with breakpoints in Notepad++. I don't think so. Yeah, render logo. It still says it's just not used. Defined but not used. How do we use it? There's something missing. If def OLED enabled bool OLED task user void. Switch get highest layer. P string. Piece adjust default. Write P, write P, write P. That's for a different thing. For the logo example, in the default font, certain ranges of characters are reserved for QMK logo. To render this logo on the LED screen, use the following code for example. Static, void, render, logo, void. Static constant, character, progmem, QMK logo. OLED write P, QMK logo. False. I don't know why that's false, but whatever. Default font files located there. OLED font H. Help. Help me. Yeah, there's no reference. I know. I'm wondering where the fuck the reference is for this. Where does it get run from? Nobody's telling me this. Where do I run it? Where's their firmware? That's gonna UF2 file. I don't want the UF2 files. SKR mini BTT, test this, shadow copy, RP2 Pico, unstable. No. Okay, so I don't have it downloaded in there. Let's see here. What is the solution? Blah, 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 blah. Firmware built QMK compile keyboards 1 key KB2040. Okay, so that's what we need to find. Hand wired. That's right. Okay, I remember now. It's in the QMK folders with all the other stuff. I don't need the downloads folder. I got a billion folders open. We're gonna have the same thing happen again. So we're looking in the QMK, not in the. There we go. This would be that's app data. Get rid of that one. I got so many folders open. It's very easy to get confused. Keyboards hand wired. A B C D E F G H for hand. Hand wired. There you go. And then we are looking at 1 key. 1 key. KB2040. There we go. Okay, so here's all the stuff. We got all the stuff. Oh, there's puppies over here. There might be puppies at the window. I don't know. I don't know if they're gonna discover where the window is. I see people wandering around back there. I got a puppy visit. Okay, so config.h. Let's take a look at that. Pragma once. Include config comment. All right. Define matrix columns and rows. Debug matrix scan rate. I don't know what that's up for. QMK waiting test by pin. Test busy pin. What? I don't know what all that shit is. Bootloader double tap reset. Oh, I should probably get that. And then define the LED pin. Yeah, let's do that. Let's get those. So we're putting that into our config.h. We need to make sure to get these files straight. I don't want to screw up again and totally destroy all this stuff. There's debug pins on that chip, so I might be able to step through code. That might be a feature, but it's not something that I can do in Notepad++, unfortunately. No, we gotta old school get over our issues here. Where's my code hiding? There it is. So we are looking at config H. And I'm just gonna add some stuff to this. So we'll just do that. I'll call that processor stuff. There we go. What else do we have in the processor stuff? RGB, don't care about. OLED display, here we go. Settings for the OLED demo. 128 by 32. Do I even have that in there? Where's that? Here it is. Yeah, I don't even have that. All right, so That was a line that was missing. All right, save that. I think that's all we need from config, right? Yes, that's all we need from config. Okay, so we're good on config.h. Next. I gotta close the window because there's conversations that are extremely distracting to me. Oh boy. It's a puppy on puppy violence. Hold on one sec. I had to mute, but something just happened upstairs. I think one of the larger other dogs did a little correction for her, our puppy, and our puppy made a complete stink out of it and was whimpering. She's not a tough dog, but it was a very pathetic whimpering going on upstairs. I think she's okay though, because they're just puppies. Okay, anyway, all right, back to what we were doing. MCU config. I don't think we need to do anything with that, but I want to take a look at the file and make sure. Let's take a look at MCU config. I know this is like, this sucks, but we will get over this and we'll make sure that everything's good. Is this the one? Am I hand wired? Okay. Oh, this looks exactly like the MCU config here, so we're good. There's an emulator? Oh, weird. I don't know if I can, yeah, I don't know if that'll exactly. Info JSON, not worried about, readme, and then rules. This would be the other one. Oh, that's all the stuff I have in there. OLED enable, yes. SSD, blah, blah, blah. Let me just take a look at where is it? Where's this thing? NAS project. We're not editing anything in the NAS right now. We should be, oh, I've got it open twice. That's why. All right. Sorry, very distracting around here right now. Okay, so we got that. We're looking at this. Here's our rules. Edit with Notepad. OLED enable, SSD, 13 whatever. The doll use I2C, bootloader, and MCU. I don't know if we have that declared anywhere. Syphlet 8. Hey, thank you for the 19 months. Yeah, I don't know if I don't think that would be useful for me. I mean, we'll try it, right? So I'll save this. And this is in our, yeah, that's in our working directory. So, okay, we've added a little bit of code, just a little bit here and there. And so that should hopefully get this thing up and running. Because, I mean, most of the stuff that we have in here, it should be fine. All right, let's give it a shot. Currently, the file system's not writable as SSI. Peripheral required for flash writing is not implemented. Ah, so that doesn't work, actually. So that thing doesn't work. Okay. That's annoying. All right. Yeah. So I think the main thing that we added was some stuff to the config. We also added the size of the screen to this thing. Is there a key map in here? There's no key map in here. I don't know what's up with that. How does that work? Are there, I guess there are other, yeah, one key.c and h. Okay, hold on a sec. So we need to look at these files now. Rows, columns, column to row, locking, tapping term, permissive hold. What? I don't think we need this stuff. Yeah, that looks fine. Okay, all right. So next we need to look at Corday 99 with 58 months. Holy crap, he's an old man. Yeah, Syphlet 8, 19, Corday 99, 58 months. Corday 99 and Syphlet 8, thank you guys so much. I really appreciate you guys subbing to me. You don't have to do that, but you do. You go out of your way. All right, one key.c. Init keyboard. Keyboard post init keyboard, debug enable, debug matrix, debug keyboard, debug mouse, keyboard post init user. I don't know what I need to do with that. I don't know if I need anything. I don't know if I need that debugging. And it scares me, so let's run away from it. Edit with Notepad++. Pragma wants Quantum H default layout. Quantum, Pragma, none of the stuff at the top. Let's check what mine does. That would be botherboard.h. Edit with Notepad++. So fuck that. Don't need that. Quantum H, that's fine. Well, Pragma wants this beast. We'll just do that. Okay, so now it's like its buddy. It's like this one. Go out of my way. It's effort to unsub. You're trapped forever. Okay, so that file's consistent. Next, config.h. No, wait, that's not. That was our board. No. This is our board. This is the one we're comparing. Rules.mk. Layouts, ortho 1x1, OLED driver. Okay, we already have that. Default folder, we don't care about. OLED enables, yes, we already have that. Yeah, we've recovered from yesterday. I looked at the code at the beginning of stream. There's some stuff that's still kind of shaky. I'm shaky about. And right now we are working to make sure that this runs. It compiled. It just didn't do anything. Oops, get back here. So matrix C, you're wondering about botherboard C? Well, this is botherboard C, and it just says include botherboard H. The other one has some kind of a thing. That would be onekey.c. It has like the debugs in it, but I don't really know what to do with those. I don't know if I need to do anything with those. I have it. Yeah, I've got botherboard.c. And that just says include botherboard H, which is what all the one key does anyway. The one key just adds a bunch of debug stuff. I never understood the mechanical keyboard fad. Feels weird, man. Yeah, I mean, it's nice to have, because the keyboard's one of your primary inputs to the computer. It's like what you're using most of your day in your gray cubicle in your gray office in the middle of the summer. In the middle of a parking lot in the middle of summer. You are on that keyboard for most of your life. You might as well invest a little bit into the tools you use every day. That's sort of my philosophy behind the whole thing. I'm not just buying a Staples chair. I'm looking for a chair that's going to support my back properly. I want a keyboard that I'm comfortable typing on, that's not going to kill my wrists, but also feels nice and just is something special to me. I feel the same way about the computer mouse as well. So I don't know. I get it. I get where it's all coming from. I just never invested as heavily as some people do. Some people are crazy. Some mechanical keyboard people are nuts. What we're trying to do is just resurrect my broken one. So it's like a carpenter buying a proper saw and hammer. Yeah, but then you get into like the weird designer keyboard stuff that exists, and there's some crazy stuff out there. You need that function? Keyboard post-init user function is what initializes the keyboard. Okay, well, I'll put it in. We'll do it. I'll do it. I'll frickin' do it. I don't even care. I don't even care. I got no holdups on this one. I'll fucking do it. I'll fucking roll with this fucking function. Keyboard post-init user. Yeah, I don't know. Okay, cool. That's part of like the user stuff that I was seeing in the other code, maybe. Normies. Okay. What else do we need to look at? We looked at rules. We looked at all this stuff. And then we looked at KB2040 for the processor-specific stuff. Key maps. What? Backlight, waiting test, hardware ID, I2C scanner. Ah, neat. Well, that's neat. I guess you can have all those wonderful I2C things going on. Shame that we don't do that. We could have done the I2C route on this and made the whole keyboard just I2C, but I felt like it didn't really. This is more fun to do with muxes and stuff if we can get them working. What's in the OLED folder? Tap dance enable. OLED enable, yes. OLED driver. We already have all that stuff. We just didn't do tap dance. What the? Tap dances. TD OLED. And it's enumerated. Test modes. Test first. Logo test first. Okay, so this is all the code that was running all those screen tests that I had. Enum tap dance. TD OLED. Should it be in enum? Is that what's going on? So keymap.c include QMK keyboard H. What am I looking at? I'm looking at keymap. Let's look at our keymap.c. Man, this really gets into the weeds, doesn't it? Include QMK keyboard.h. Okay. Oops, no, what am I doing? I got to keep my head on straight for this, guys. I'm starting to like lose focus. Static enumerate, test mode, test first, OLED rotation T. See, I got the logo running on the thing. I think we got the single, this is like the test that we got running. We were just going through folders and uploading stuff. Dance OLED finished. Where does this stuff get called? Is it because it was like in a enum, it just goes through everything and runs it? I don't understand why this code, maybe there's like a menu down here. I've highlighted the name of the function, so I'm just looking through to see what's happening here. See, like here, it's got key maps, matrix rows and column, layout, ortho, one by one. It's like defining a whole bunch of stuff that we didn't have in other parts of the code. Holy shit, this is a lot of code here. Rotation, task user. Oh, I think this is where the function gets called. Oh, maybe not. Keyboard post-init user, debug enable equals true. Console messages are used for the update speed test results. So do I need to like include that? I mean, I think I need that at least. Oh my God. So many key map thing. Because we just have a function in here that's render logo. And it's not being called anywhere. Fill horizontal, fill vertical, test logo, case, test mode, test logo, break. OLED task user. OLED task user, the sample implementation of OLED task user in the documentation redraws, what is this doing? Image after every call, relying on the fact that drawing functions check whether the output actually, so OLED task user might be what gets run. And maybe I just need to, what the hell? Maybe I just need to run it in that function. Maybe I need to call an OLED task user. What the hell? I don't get this. I don't get what's going on. Test slow update, test characters, get test character, frames. Jesus Christ. Yeah, it seems like that might be the case. OLED task user, and then I can just run. Why is it a Boolean though? Oops. I don't even know what I just did. Copy that. I just fat fingered something and it went crazy. Need update is equal to true. Return false. It just returns false every time. Hey, what's the result of this function? It's fuck you. That's what it is. These are breaks, not returns, so that would just break the switch. Yeah, that's the test mode. And then the test mode is running test fill, write P, test characters, test slow update, test logo. And then test logo. Okay, so I think the task user is what's called, and we just return it as false. Right, that's what I was gonna do. Yeah, so render logo. So what we need is, and this is keymap.c, if def OLED enable, bool OLED task user, and then we just do render logo, bada bing, and then return false. Render the logo and return false. That's all we're doing right now. I'll have to look up more complicated OLED functions. Man, I can't, like, the documentation was just like, yeah, just like put this function in there, and it's a static function with no call. It's like, what? How to, huh? What? Huh? Okay, save that, and we're saving that on the C drive. Close the confusion. The one thing, I mean, the other thing that we might run into trouble with is that the test function that I put in there too. We got a couple little changes in there that I think will hopefully get stuff to run properly. What does this read the documentation? I understand the individual words that you've typed, but when you put them in that order, the other thing that might not be happening is my keyboard code might just not be executed. It might just never be doing, you know, like the matrix scan. So I probably need to look through that and make sure that all of the appropriate calls at the top of all the stuff at the header of all the files is properly set up so that things run. Because I think that might be the problem. They literally mention it in the doc, then your keymap C file, implement the OLED task call. Listen, you little shit. All right, so. No? Huh? Oh, I'm running it twice. A program's so nice I ran it twice. Close that. All right, let's try again. Default flash. Firmware 0.18. Let's see what happens. The only problem is when we have an error that doesn't show in the error logs. Everything's set up properly, but just doesn't work. Ah! Okay. Task user. Implicit declaration of the function render logo. Render logo. Oh, conflicting types. Static void. Render logo void. Why is it conflicting type? I'm not doing anything. I didn't do anything. Why is it a conflicting type? That's the wrong one. It should go above it. Okay, hold on. Oh, is it? Ah, it's one of those. Son of a bitch. I hate those. All right, I'll fix it. Where are we in? We're in oh god, I just need to go to the folder. You are the NAS folder. You're the one. No, this is the wrong. This is QMK firmware. Did I close the C drive one? No, that's this. Okay. Okay. So just an order thing that it has this OLED task user that it wants to run, and it tries to run the function, but it hasn't even looked at this yet. So static void just means that this only functions within this file, and then this is what the processor runs in order to do that stuff. And then post-init user, I'm just putting in there for the debugs, I guess. Okay. Bada. Bingus. Because if we can get a logo to render and the pins are not doing anything, then we know that it's a problem with the just the calls and the loops. Calls and the loops. I like what I see. I like what I see. We've got a bunch of OKs going in here. Got a bunch of stuff, doing stuff with stuff. In and out of stuff and around the stuff. And you combine the stuff and you look at the stuff and you go, this stuff is shit. Wear leveling, huh? What the hell is wear leveling? What is that all about? You can do some pretty crazy stuff with QMK. I mean, you could do like analog keys if you had the hardware to do that. Actually, I'm kind of shocked that we don't have like 120 Hall effect sensors inside of a keyboard and use magnets for everything else. I guess magnets might harm the longevity a little bit of the keyboard because if metal gets in there. SSD wear leveling. What? Why is that necessary in a microcontroller? What's happening here? MCU for flash wear leveling. That's wild. That is wild that would be included for the. It's for the RP2040, I think, too. Oh my god, this is taking forever. Yeah, this is Chibios. Importing all the Chibi iOS stuff. Like UART and USPA and WSPy and NVIC and HALD and role-playing drama, RPDMA. Yeah, at least they're okay. And null streams and buffs. And we like buff streams more than we like null streams. A lot of clocks, a lot of timers. Man, this thing is extensive. I think we're getting close. There we are. All right, so unplug. Push the button. Plug it in. Flash-mated. Hey, we got a logo. We got a logo. We got a logo. Let's go. Okay, so we got the logo to run. Now that we understand how the goddamn software works, we were able to get this thing up and running. So our next step is to figure out why none of my stuff is running. What could be happening? Well, let's check to see if the muxes are being used at all right now. Nothing. So there should be frantic ones and zeros visible on these pins. Some of them have actually gone high or low. Just check here to see. Nothing there. Yeah, nothing. Whole lot of nothing. Whole lot of nothing. Whole lot of bingus. What's going on over here? Hey, I2C, how's it going? I2C is a flurry of activity. Or is it? Is nothing happening on I2C? What's going on here? Oh, maybe I'm just looking at a voltage level. Hold on. Let's try the other one. There should at the very least be a clock visible on this thing. There's some activity there. SDA and SCL, what are you guys up to? Is nothing sacred anymore? How come I'm not? I am not observing a clock on the I2C line, which is a problem. Oh, because it's off. Hold on a minute. I'm going to unplug this and plug it back in. Okay, it's hard to unplug. Ugh. Plug it back in. There's the QMK firmware, and there's my clock. Look at my clock, chat. It doesn't seem like a very good clock. I think maybe I'm observing it. I'm probably observing it the wrong way. But that line looks like it's stressing. Okay, nothing there. Nothing there. Check over here. Yeah, nothing doing on the mux lines. Nothing doing. We gotta look at that next. All right, I'm gonna do a bathroom break real quick, and then we'll look at what's wrong with the rest of the code. I think something isn't executing, and so it's not even trying to run the matrix right now. I don't think, and it just something. I probably just lost something along the way. So we can compare it to. I mean, we can just stay within the OLED code and just cross compare to see what's happening there. Wasn't connected to chat. Now I'm connected to chat. What's going on? Yeah, give me just a minute. I'll be right back. And then we'll get into the nitty-gritty overlays. You guys do this one. That comes up on screen. And then I will put on music. Don't need to look at Discord. There's my music. Okay, there we go. Let's do more FTL. More FTL music. BRB. That's right. I'm version controlling with video recording. I mean, that's what I did. I had to go back into the VOD and look at all the stuff. But I think what got lost in the fray there is some calls that are needed in order to run the matrix code. I didn't. What is this one? Random off-topic question. Boop. Where the fuck? Where is this? Random off-topic question. Did you end up sticking with the Omnipod 5? My son has about 2 weeks of Dash left before we switch to the 5. I'm curious how it worked. No, I did not. I'm staying with the Dash until the 5 gets hacked, because I'm using the OpenAPS system, which isn't Omnipod software. So under the OpenAPS system, you know, these guys have not hacked the Omnipod 5s. So I don't use it. I don't know what the use is. I don't know what it's like to use them. I'm getting used to just having an Omnipod now. I don't have a cable sticking out. When I went upstairs after yesterday's cock up, I was playing with the dog, and she immediately found the microphone cable and started chewing on it. So I'm glad I don't have the tube running over to the insulin pump at the moment. That's kind of a minor thing, but I mean, also not having a pager on me constantly that is attached to a Band-Aid on my body is kind of interesting. I'm getting used to the pods right now, but yeah, that shipment of Omnipod 5s, I'm not doing anything with. I'm just not using them because I bought a new Android phone, and they're not compatible with a new Android phone, or at least at the time they weren't. They might still not be. Spray all your equipment with bitter. We tried bitter apple, and I think my dog likes bitter apple. I think she likes bitter apple because it doesn't do anything. It doesn't do anything. A corgi is too willful to be dissuaded by bitter apple. All right, so what's not happening here? Nothing is happening with the muxes. They're not doing anything. Now we've got code in our default key map. We need to look at the other. This is still C drive. We got to make sure that we're in the C drive. I got backups on everything. Yeah, we got to see what's happening here. Nothing. It feels like the matrix code just isn't running, because if the matrix code was running, we would be getting something out of these mux pins. They'd be doing stuff. So what we need to look at is the OLED example that I was able to successfully run. All right. So in the QMK firmware, keyboards hand-wired one key. We're looking at the one key. I want to see what they're doing. Like, for instance, is there any matrix stuff going on here? Probably not. It's probably running the original matrix, which is why it's not here. We need to find something that redefines the matrix. I guess for that, I can go to the examples that I had before. On a file, what redefines the matrix? So that would be in, let's see, where did that tutorial go? Not the tutorial. We don't need this anymore. OLED driver, I don't want to look at anymore. It makes me sick. QMK OLED, this is my search. That's the Adafruit thing that we were following before. That one we can close. This one already has its own thing, and it's working within the matrix. We're looking at how to run a custom matrix. So QMK custom matrix. Mechanical mechanism supplement or replace the default matrix scanning routine with your own code. Reasons for this feature include you're a weirdo, irregular switch matrix, and you're a weirdo, or maybe you're just a weirdo. Implementing custom matrix, matrix.c. So we put matrix.c, and we need this. Haha. And to configure compilation for the new file, add this to your rules.mk. Well, how do you do? I'm not reading chat right now. I'm trying to figure out problems on my own. It's not that I don't want you guys helping me. I just wanted to see if I could figure something out on my own. Yeah, QMK, GitHub. Yeah, see, you're telling me to do exactly what I just did, which is fine. That's fine. That's actually totally fine. This isn't rules.mk. I need rules.mk. It's all good. Where am I? I need to look in the C drive. Users, oh bother, QMK firmware, board. Yeah, this is the one. So we need to go to rules, edit, and do that. What else do we need? I didn't know we needed to call that directly from here. Oh, right. We don't want, I don't think we want light. I think we want full. Default implementation for various scanning functions, reducing the boilerplate code when implementing a custom matrix. To configure this, add this to, no, full replacement. Custom matrix equals very yes. Configure, add this to your rules.mk. Rules.mk. Blit. I don't know if I need to, like, peel this off. There's a custom keyboard site that converts your layout to QMK. Yeah, I've already used it, and I showed it on stream earlier. I don't think I still have it open, but earlier in the stream, if you want to look at that, it helps you figure out your key map. You can define where the rows and the columns to the keys are, and then it'll generate the files that you need. Implementing the following functions in matrix C. Matrix print. What is that about? What a print? We don't have anything for print. we have, let's see, matrix row T, matrix get row. No, we're doing, I think we're doing matrix scan. Provide the following defaults for callbacks. Matrix init KB, scan keyboard, init user scan. I think I already have everything. I think my matrix C is good. Users will bother, blah, blah, blah. Okay. Matrix.c, edit with notepad. So we've got matrix init custom and matrix custom matrix equal to very yes. And then matrix scan custom. And that uses our static bool, read columns on row. But read column, it doesn't matter. These two functions will now be called because we have this. We have the source plus equal. I don't even know if this is necessary, but we have the custom matrix is equal to yes. So I don't know about this stuff, though. I don't know if we need this or not. Callback defaults or matrix scan. See, we have matrix scan custom. Oh, here we go. Yeah. Oh, light does. Wait a minute. Oh, so we want light. We want light because then we get these two functions. Ha. Save that. And then I think we're good to go. We want light because we just want these two. We don't need everything. Get row, print, init, scan. I don't know. I mean, maybe we do. I don't know. I think we're okay with light. I don't, because you need all this shit too. Okay. We'll just do the light function. I think we're ready to go. So that's why it wasn't running. It's because we didn't tell it there was anything different. We didn't tell it what was going on. I am understanding this more and more. It's unfortunately we've had to take like an amalgamation of different sources of information, but try again. Does that logo thing go to sleep after a little bit? Looks like it does. I'm gonna make myself cough. All right, come on, buddy. Give me all those OKs. I need all the OKs in the world. I need them all. Every single Brit. Shit. Row pins is undeclared. Did you mean column pins? Listen here, you little fucking shit. If row pins are the current column. All right, so I need to put that back in, I guess. Even though they're all no pin. Because, yeah, there were two variables on this one. One was for rows and the other columns. And I guess, even though this should never, because they're all no pin. Row pin, matrix, rows, matrix, row pins. Okay. Pin T, constant, even though the pins are all no pin. Question void. And then I don't even know where did you even get that? Where'd you get that row pin from? Line 20? Oh, okay. Wait, oh no, that should be column pins. Column pins of the current column. Yeah. So I don't actually need this. Oh yeah, if syphilid 8 shows up again, I apologize about missing that question. If they pop back in. For current columns equal to 0, matrix, column. Yeah, I did mean column. Okay. So the compiler read my mind. Function matrix custom error implicit declaration of read columns on row. Read columns on row. Oh, you're here for it. Okay, good. Thank you. Yeah, that's like on a level that I can't just, I can't just brush off comments like that. Like, oh, streamer didn't hear me. I guess I'll, you know, do something horrible health-wise. Something, you know. Read columns on row. Error implicit declaration. Conflicting types. Static boolean. Read comments on, or read columns on row rather. Read calls on row. There's not a lot of functions in here. Static boolean, read columns on the row. Matrix change is equal to false. Return matrix changed. What's the big idea? If it's a boolean, it should be able to go into a statement like that. Columns on row, static bool, columns on row, botherboard, matrix, blah, 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 blah. Previous implicit declaration, yeah. Calling it before it was declared. Read columns on row, yes. Yes, that's what it was. Okay, that's what it is. It's an order of operations thing. Oh, I hate that. I hate that, because the flow, the explanation flow of what's happening here is confusing when you run it up like this. But apparently you need to declare it first within whatever this compiler is. I like the Arduino where you can compare all the little functions afterwards. Yeah. My streamer told me to put okra in water and then drink the water, and that would cure my diabetes, and then I died. I know, it's 2022. Why are we worried about this? Why are we not scanning it all into memory? Oh well. Okay, try again. We had okra from a friend's garden that we made gumbo with, and unfortunately the okra was a little too old, so there were fibers in it. So we're like eating this delicious gumbo, took all day to make, and I like keep chewing. You just keep chewing, keep chewing, keep chewing, and then you're just like, what the fuck? I don't know what you're supposed to do about that. Here we are again. Row pins. Did I mean column pins? I did. Didn't I change this? Did I not? Is this not good enough? Did I save? I am editing the one that is in C users, and I'm looking at, oh shit. Column pins of the current column. Jesus, I didn't even correct it. Yeah, it was good. I put a little bit of rice at the bottom of the bowl and then filled that shit up with gumbo, and then I sprinkled a shit ton of Tabasco sauce on it, and the carbohydrates were just enough that my system handled it without even going hyperglycemic. I was super happy about that. It was a very strange and rare occurrence. This looping shit is pretty crazy. It's handling stuff really, really well. I'm able to get a response to insulin a lot faster than I typically can. God damn it. What do we do? Current matrix. Read columns on row. Current matrix undeclared. Hey, I gotta rearrange all of my code so that it's confusing to read. That was line 50, right? Why did it tag this one and not all of the previous ones? Current matrix is down here, so this needs to be plucked and replaced up here. I like the other order of operations where you can scan down. Wait a minute. Didn't we just move that? Hold on a minute. Matrix row T, current matrix is declared here. But then read columns on row is this function. But wait, this is declared up here. Oh, did I, too many R's? Ah. No, it's no. Current matrix, current row. This was hand transcribed, so. Oh, 3 R's. Son of a bitch. Where's this 3-yard motherfucker? Where have you been hiding? Where? Control F. Triple R. Found you. Delete. Okay. Control S. Yeah, let me suss through it. I'll get there. Make finished with errors. Okay, Control S and try again. Hey, at least we're getting somewhere. At least I've like got an idea of how this program works. Now I got all this knowledge about how to run a custom matrix on a keyboard. I'm never going to need it for anything else. Ever again. Unless my backup code keyboard explodes. The friend who bought the exact same keyboard as I have is upgrading or getting a different keyboard. And he's like, you want the old one? And I'm like, yeah. Like, holy shit. So I'm going to have 2 code keyboards kicking around so I can throw out all of the keyboards that I bought as temporary replacements to under $30 keyboards. Finished with errors I don't like. Our default elf has errors. Make 1, build defs, common rules MK, build motherboard default elf, error 1. What the frick? What is this? Max 308, column init. Undefined reference. Oh, do I need to include? I thought I did. Include max 308.h. Max 308 column init. Init special. Column init, row and column init, void. That's here. Stint, sdbool. I don't know if I need to declare those in there. And then the other one is this one. Row init, column init, set row adder, set column adder. Make sure that these are actually the ones that are in the matrix.c. Yeah, column adder, row adder. Matrix.h, quantum h, max 308h. But then the H file, does the H file need to include the C file, or does the C file need to include the H file? I forget which one it is. Let me reference their driver file, which is, where is that? Oh my God, it's so many folders. All right, so we're getting out of one key. Yeah, let me just confirm. I want to get to drivers, and then we're looking at GPIO, and then this is a different, so the C file, and then the H file. C file, then the H file, pragma1, stdbool, does all that stuff. It does not include in the H file anything about the C file. Max 308H, yeah, that's good. We're good on that. The C file includes the H file and GPIO, which is what I have. So that's correct. Yeah, but it's not compiling the C file for some reason. So do I need to add into the rules source max 308.c? I don't know if I need to do that. You're literally telling me to do exactly what I was doing. Damn it. Stop it. Pyro's engaged in the project. He wants to basically do it as well. No, but it's good to have somebody at least backing up my thought process. It's weird that you would have to add it as another source because it's referenced in matrix C, so you would think that that would just add it, but I don't think it is. Weird. It's weird. But anyway, yeah, that's an extra driver file that I have, and I know that there was, I guess there's an include. If you have it in the drivers folder, you would add it to the rules that you're adding that thing as well. So I guess this will just hopefully just make it compile with the file that it needs. Compile with the file. All the other files are standard. So give it a shot. Freak out. And I did ADDR instead of ADDY. I should have done ADDY, but I kowtowed to the internet calling me weird for calling an address an addy because it's adder. But adder doesn't roll off of the tongue. I guess it kind of does. It kind of rolled off the tongue just then. What the hell is that thing? Oh, it's a JoJo thing. Okay. All right. Okay. Okay. Oh, bootloading. I feel so much more in control of this code. All right. It yoded the code into the thing, and now nothing is happening on the MCU. Whoops-a-daisy. Let's go over to this view. Show you guys what's up. What's up, what's up, what's up? Nothing's happening. I don't get any pin activity. Yeah, nothing. I try unplugging and plugging it back in, because the screen should still be turning on. Unless part of my code... Oh, there it is. It turned on. Oh, baby. All right. We got something going on over there. Something's happening. It appears. Now, without any hardware hooked up to this thing, I guess the GPIO are set low automatically, but like, what kind of timing is that? Holy shit. Feels so good to be in total control. I really want to auto trigger. Trigger menu, and whoop. That one, take it down to there. And source is channel 3, source is channel 1. Yes. When we'll do transition instead of, wait, what is this? No, I don't want any of these pulse modes. Oh, type pulse. Pulse, we're just going edge. Give me that edge. There he is. Woo. All right, so that's one of either the addresses. I don't know, I just went to some random pin, but that's basically probably it counting through the muxes. So I guess the other question is whether or not I can actually send it to press a button. Yeah, right now this is 50 microseconds on the screen. Or it might be per div, I don't know. It's not a lot of time. This thing runs very quickly. Okay, we're in good shape. So what happens if I set one of the pins to high? And that would be GP 2 and 3. So that's all the way up here. There's nothing coming in from the muxes. They're just set low. And so if I take a jumper and I set it high, and my cursor is currently in the Twitch chat, nothing. What voltage is that? I don't know what voltage I'm setting it to. I don't want to blow up my Raspberry Pi with 5 volts. That might be 3v3, and then this one is directly getting 5. Yeah, there's one wire going all the way over there to 5. Okay, this is 3v3 here. Yeah, none of the buttons are pressing. Which is depressing. Wait, the screen turned off. Should probably do it through a resistor, to be honest. Well, no, it's going through an internal pull down. Give me this cable back, you freaking thief. Plug that in. QMK firmware. Little tappy. Well, Nightbot chimed in. No, I'm not getting any keyboard presses out of it. Ground. Positive. Yeah, let me try the other one then. GP. Is that actually GP 2 and 3? I think it is. Hold on. Raspberry Pi Pico pinout. Gotta look it up. Pico pin out. And then GP 0, 1, 2, and 3. So that's 4 pins down from the top. Oh, so this would actually be 1, 2, 3. Yeah, 4 and 5. 1, 2, 3, 4, and 5. I got nothing plugged into that one. Oh my God. It just opened up bringatrailer.com. What the fuck? The keyboard works. It's fucking with my system. It pulled up QMK and it pulled up bring a trailer and then looked at the source code for it. It type anything obscene into the Yuita. Yeah, so it works. It actually types stuff when I short out the pins. Hey, I think we might actually have a functional thing here. So I need to hook this stuff up to a particular row and column, and we need to see what it can do. So let's go back to this screen. And then I need to look at, well, actually, I just need my paint document in order to figure this out. Yeah, it's alive, and if I give, basically I was giving 5 volts to this, and then it would be typing random shit. It just wants a trailer. Hey, I'm excited about that. That's cool. So let's hook up our 2 buttons, and we'll just give it, because we've only got the one, only this is hooked up right now. So we have, I mean, do we have 3 volts running this thing? Let's just take a look at all the, what we have hooked up. Yeah, I need like, yeah, we need that view. We're gonna get up and close with it. Try to back us out as much as possible. We can see a little bit more. So I got my 2 Max chips here that are sold, that their labels are wearing off a little bit. Ground on that pin, and then those are connected to 5 volts. This is the 5 volt pin right here. The input, what is that little wire doing there? That's concerning. What is that little wire doing there? What is that? What do you, hold on a minute. What are you, huh? Who invited you, little wire? That's supposed to be in there. All right, so my schematic. All right, so we've got the schematic here. We got pin 1 right there. We need 3.3 volts on the common pin of the one that is hooked up. Let's see. So this, oh, we're actually connected to GP3. So oh, did I change cameras to show? Yeah, you guys can't see. What I was doing is I was taking a jumper to GP2, this pin right here, and I was connecting it to positive power. And what that did is it typed a bunch of bullshit on the, because as it scans through, it was registering that things were being typed. And so it totally fucked up my computer because it just typed random stuff. But yeah, we'll be able to hook this up and actually get it running keys. But first, I need to make sure that the muxes are performing properly. So we need to hook this thing up with the muxes. Now we've hooked up the muxes so that they're getting all of what I assume to be all of the control signals going into them. So this is the only thing that's missing from this breadboard is the 3rd mux. I have a feeling I'm going to be gluing these directly down to the board, but these muxes, 2 of them will be sharing all of the same pins basically. It's just you know, doubling up. But then the other mux is our power supply one. So which one is supplying power? That would be A0 on enable 0. So that's these, and those are going. Oh God, I don't even know where. I think this one is the first one, and so we need to put the common pin two 3.3 volts. I don't have pin numbers on this thing. Oh, man. We got to open up the data sheet for this thing. Oh, I'm so happy that that all worked. Holy shit. That was cool, man. We've implemented a custom matrix in this thing. No, it's one row and one column. We're basically just taking away the doubled one because we don't need to test it all at once. We can just test the two and see that everything's working properly. There, let me just do this. Because I'm gonna need to do more work on this thing, so I'll just put this in the paint document. Look at you, right over there. Isn't that nice? Let's turn on clear backgrounds. I can position the. Oh no, it's not a totally clear. It's not a clear background on the thing. Oh man, where can I put you? Just go right there. Then I can close crop it and just put it right there. There we go. Okay, that's because like this way I can see everything that I need to see. All right, so the pin that we want is common, pin 8, and that one needs to be on 3.3 volts. That's this one here. We need to put that out there. Easy peasy lemon squeezy. Easy lemon squeezy peasy. With a cherry on top. Where is that? Yellow jumper, I guess? My yellow jumper. Man, I don't wear yellow jumpers enough. Oh no, that needs a blue. That needs a blue. It's a little bit longer. So yeah, pin 8 of this one. Ah! You are following a streamer that is a big JoJo fan, huh? Okay, I'm trying to get it under these, but I'm gonna, like, these are gonna pop out, and I'm not gonna know where they go. Whoa, what is hot over here? Oh, no, never mind. I'm just bumping against stuff. I just moved the keyboard carcass for a second here. Oh, we're not even on a view where you guys can see what I'm doing. There we go. What I'm trying to do is just sneak the jumper in, like, right there. Ah, but I want to be under... This breadboard setup is starting to get kind of annoying. There we go. Into positive 3 volts. Come on. Ah. God damn it. This is hard to do on the microscope. Use the tweezers to help me out here. Oh yeah, that little cut right there was me slicing tomatoes with an extremely sharp knife. OctoJ recommended a knife to me for my main kitchen knife for cutting. And I was cutting these homegrown tomatoes that have extremely tough skins. And I took away just like barely a layer of skin. I don't know why that hasn't healed yet, because it didn't even bleed. It like barely bled. Blood. Wahaha. Okay, now one of the multiplexer rows I will simply take and I will connect it to our switch. So we can take any of these rows that'll be activated. I can just plonk down that. Yeah, it's a very sharp knife. And I will connect that to one of my switch leads. Now I could make this into a matrix if I really wanted to. I could do row. No, wait, there's only 2 switches. I really can't. Well, okay, fine. So we'll just take random. I need to make sure that that's actually a proper pin. Wait a minute. Yeah, the address pins are up top, and then the NO pins are down here. So if I just connect this to basically any of these, let's pinpoint a key just to make sure our key mappings are correct. We'll pinpoint a key because we're looking at the second bank of pins. And so if we look at the second bank of pins, we can go with, okay. We can go with, yeah, I don't know. Looking for like, let's just like do the P key I think is very close to 0, 0. Q. So those two I need 9, 1 and 9. So actually that's pin 1 to pin 1 would be the Q key. Or no, 0 to 1. 0 to, hold on. 0 to 2. 0 to 2 would be the Q key. So that would be row 0, column 9, which is this one. So I want NO2 of the lower one to go to the one side of the switch. Okay, this is going to very quickly confuse me. So NO2 go to the other side of the switch. That's this one. And NO2 is located pin 5. 3, 4, 5. So this one right here. I want this to go to the other side of the switch. Now there's only 4 things plugged in here. It actually should be here. Let's row and column on that. And so now presumably with this thing running, I should be able to push the button and then type Q into chat. Try to get it all on camera. I can't get it all on camera. It's just not going to work. I can't get it all on camera. I can't show you guys what I'm typing on the computer. So what I need to do is plug it back in and just see whether or not pressing the button types a Q. It does not. For those of you at home, observing at home, it does not. Okay? Cool. Great. Is it a breadboard thing? Nah. All right. Yeah, it didn't do it. Okay, hold on. So that didn't type what I thought it would type. Well, wait a minute. Is that the proper row? I don't think that's the proper row. It might be a non-key. The proper row is row 0, which is pin. Which one is it? Pin 4. So this would be 1, 2, 3, 4. This one. Now, if I press this, and I'm going to put my cursor into the window here, it does nothing. Of course, that's what I predicted. Damn it, it's not doing anything. This one, pin 8 is common. Oh. Oh. What is that even? That's not even doing anything. This is like the wrong... This isn't pin 8. Wait, is it? Oh yeah, it is pin 8. Oh, which means that this is pin 16. Oh, I messed everything up. This is the problem. Yoink. And then I need to do this pin 8 needs to go to... Oh, it already does. Okay, well, can I type a Q now? No. No, that doesn't work. Let me unplug it or hit the reset button. Double tap. No, nothing. Why is it shutting down after a certain amount of time? Well, it might be tired of my shenanigans. That might be one thing it's doing. Okay, plugged in there. Press the button. Nothing's happening. We know that it's capable of typing things. I'm holding down the button. Nothing's happening. So it's probably still a me issue. Probably still a wiring issue. I mean, is it scanning? Let me check on the oscilloscope. Oh yeah, it's scanning. Oh, it's scanning. Oh, he be scanning. He's scanning. Which means, let's see, QB. This one is the signal. And that one runs all the way down to there. What is that pin? That's not the common pin. Wait a minute. GP, okay, so GP1, GP2, sorry, 0, 1. We should be on 2 and 3. So 0, 1, ground, 2, and 3. So we're plugged into 2, actually. So we're on GP2, and that's running all the way over to pin 8 on the column scanner. This one's pin 8 is going to positive. We're hooked up to GP2. And we have 1, 2, 3, pin 4 of the rows. Pin 4 is NO1, which is our 0th row. And then we have on the columns, we have pin 1, 2, 3 connected to ground. Yes. 4, 5. Pin 5, which is NO2, which is column number 1. That should be the Q key. Q key. How kooky. If I've wired my button up correctly, which I have. Q key. Yeah, it's not doing anything. But when I connect the pin to positive, it does stuff. Wait, oh, but I need to be on GP3. Nope, that was the wrong one. Put that back. All the way over here. I need to be on the pin below this one. That goes all the way to pin 8. Correct. Okay. So now if I hit the button, nothing. But the screen isn't on. I don't know if it's going to sleep because it's not seeing any key presses. What if I connect? What if I do the jumper again? Oh, have I enabled both of these? The enable pin is pin 2. Yeah, I did. I enabled them. Let's pin 2. No, I haven't enabled them. So they might not be. There's no enable logic in here. So we need to get rid of the pin 2s and we need to connect those to positive. It's getting claustrophobic. Hold on, let's get up here. I haven't done the enables. So pin 2 of both of these. This one is pin 2 on the blue wire. So the blue wire goes away. I don't need that anymore. My freaking leads are popping out all over the place. Pin 2 also goes away on this. This is the argument for having a bird's nest of wires, is this kind of stuff where you have to edit things. The bird's nest of wires, your wires aren't sitting on top of your wires and preventing you from unplugging stuff. But alas. So that's 3 connected to there. We need the 2 enables. So I need those to go to. How does the enable pin work on this chip? Where is my chip? There it is. Enable pin. Scroll, scroll, scroll. Turn on time. 85 nanoseconds. On resistance. Hold on, I need to put this on a better monitor to read. Blah, blah, blah. I mean, it responds to the 3-volt signal, so I would assume that enable. Turn off time, turn on time. Pin 2. They're only concerned about time in this data sheet. I don't know what the signal is. I think 3 volts should be okay for this. So I need to do the pin 2s. I need to connect them to my 3-volt bus that runs throughout this breadboard. I just need some very short little jumpers on it. Oh, you're not even. I'm not even camera. All right, hold on. We'll get this thing running. The whole point of this test is to make sure that it's able to press buttons in a timely manner and not have like a significant amount of input lag. And I'm not really seeing that from when I connected the pin to positive, but we also need to make sure that the scheme that this thing is running is working. So pin 2, positive. So they're constantly enabled. There is no sleep for this keyboard. Which, you know, I mean, I guess I could probably build in like a sleep thing on the keyboard if I wanted to. Pin 1, pin 2, there's pin 2. This jumper's a little short, but it should be able to do good work. Okay, close enough. Close enough. Okay, now, presumably, everything should work. Plug it back in, see if I can type Q a bunch. There's the logo. Go into chat. Huh? No, that slipped out. Heh! Yes! Yes! Hold it down. Yep. What I'm doing is I'm looking at how it's typing it. Yeah, it needs a little bit of debounce. It's not necessarily double tapping, and the repeat is happening very quickly. Yeah, it'll sometimes double type when you press it down. So I'll have to add that, or maybe change the repeat timer. But okay, we've done it. Oh my God, that sucked. I think the next step for this is going to be to start wiring it up to the actual keyboard. And then I have to figure out what the hell I'm doing with the screen. But I mean, the Q key types pretty quickly. I'll have to see what the timing is on it, but it seems like everything is working very, very nicely. I mean, the repeat scanning, I don't know what time interval that's happening in. That might be what the repeats are. No, it actually seems to wait just a second before it keeps repeating. Yeah, and the regular keyboard does that too. I just had to confirm that by trying out my own keyboard on this computer. Okay, this is ready to be implemented in the main thing. I think what I'm going to do is we're going to have to do a little bit of like desoldering of some of this stuff over here. So I guess for the next like 2 hours, we can remove all of the old stuff on this keyboard that we don't need, which means like ripping out all of this, all this circuit junk that's in the way. Getting the backlight running is another thing that I need to actually figure out, but this is a struggle. I mean, we finally got the firmware on the chip and running the muxes, and it appears as though the muxes are running fast enough for me to really take advantage of the, you know, of the QMK system in order to run my keyboard. I'm excited about that. What we'll do is I'll remove a lot of the chips from this area, and then I think probably the best thing for me to do is to just find an open area and put down some Captain tape and then glue the chips down to the board and then run everything flat against the board. What caused the old keyboard controller to give up the smoke? I spilled stuff on it. And I have a feeling I'll spill stuff on the revamp as well, and it's going to also cause utter chaos. Do you have a plan to mount the display? Yeah, I'm just going to drill 4 tiny little holes here. It's going to go right here, and so this thing is on an I2C. I mean, I could get that screen that we took out of the 1-drop glucose meter and use that, but this one has all the stuff on it already that I would have to add to the other one. So if I want to, see, I was just going to put the screen right there, and then maybe I can like print out a bevel for it that'll just kind of like make it look like it's part of the keyboard. I don't really want to mess around with cutting a square hole for it. I don't trust myself to cut something clean enough. So what I'll do is just install it here, you know, and just cut like a little hole for the header, and that's it. Keyboards are consumables. Oh God, I hate that that's true. Yeah, we did it. That's pretty crazy. I can't believe that that worked. All that custom code. I'm putting away my multimeter for now. Yeah, let's prep the keyboard. I don't think I want to use hot air on this because it's going to damage a lot of the, you know, you got the plastic keys everywhere that'll get very easily damaged by hot air. So to get the old stuff out, I believe the best route is going to be to use solder and chip quick. Or just solder. I mean, this stuff is small. We'll put on the giant chisel tip and see where that takes us. see if we can't do a little bit of old school bothering instead of all this programming bullshit. We got a lot of programming bullshit in the future. When we get back to burn the subs, we need to finish the Fusion 360 designs, seal the 3D print so that it holds water, and then it's all software from there. It's all software all the way down. Yeah, QMK is wild. This scheme that I came up with the muxes is also kind of weird and unorthodox. Unorthodox. There we go. Not doxed. What am I talking about? I'm kind of weirdo. You're making up words. I wish we could finish today with a working keyboard, but that's like a lot of work. But let's get down to brass tacks with this, and maybe we'll do a Saturday keyboard work stream. That's probably what we should do, because then I'll be able to finish this thing. Put the breadboard back together. I'm pretty happy with the test, though. The speed of it is it doesn't concern me. I was tapping the button frantically, and everything was coming through properly. And I think just with like a tiny little debounce on it, it'll be completely stable. Yeah, QMK is extensive. I need to look up what to do with the screen, because it's not like I'm gonna run multiple profiles or anything, right? I don't think so. Okay, that landed all the way on the floor. Oh, and it jettisoned some of its contents. That's nice. The jumper kit just fell all the way onto the floor. All right, that was the I2C port expander that we don't need. It's weird though, because some people, like with the split keyboards, they just run an I2C port expander on the thing, and it works perfectly fine. I'm trying to like move stuff around so that I have a bit of room to work. Right, yeah, it's very easy to get overwhelmed. I think the main thing is I should have read the docs, like the official docs, because the official docs had all that information that I needed. It's just they weren't, I don't know. It wasn't display. Once again, going back to my frustrations with Adafruit, they weren't exactly. I mean, how do you even start with that? How do you even explain something to me properly? I don't think that's possible. But like, explaining that these functions are running from the main code and that they need to be declared, and then files that are added need to be declared in the main code in a particular way. It's I don't know. It's starting from, I guess I'm starting from a point that's a little bit more advanced than what they would expect. Because typically you'd start from a point where like, I have this keyboard and here's the code for it in these files. Like, it's like the whole thing is already there. You don't need to do any work. But we needed to understand how these files were being run in order to manipulate them into a weird thing that people don't typically do. With parts people don't typically use. Who's out here with Max 309s in their whatever, paddock of parts? All right, back to hardware. Man, this feels good. I appreciate working on hardware. This is what I'm good at. I'm not great at coding. I guess I'm all right at coding, but really, my talents lie in what you're looking at in front of you right now. Yes, I shall now remove stuff from this board with a blank check. I'm going to leave transistors and the resistors on those transistors. Transistors and the resistor on those transistors, because this is the RGB, this is the backlight. It's like some kind of Darlington, I think. We'll be able to see it a little bit more clearly when I remove all this stuff. And then all the way over here, we have the high side drivers for those RGB LEDs. I don't know what the hell is possibly going on with that, or how QMK even handles backlighting LEDs. I'm hoping to figure it out, though. I'll have to look it up. Now that we have a bit of a better understanding of a QMK. I got like all this mess over here that I'm trying to mitigate. You guys can't see it. You can't see nothing. I don't see nothing anymore, bother. Well, I got news for you, kid. That's a little unnerving. The change in thermal properties when I breathe. It's me, streamer. We need to work on alternative visions more. I need to get that 3D Connect view back. I could do game streams and I could have this total fucking like cyberpunk look with thermal cameras and shit. On the thermal, yeah, the thermal's got a good frame rate. It's the group gets like a thermal webcam module. That's what I want. Specifically, I wanted it to be a webcam. I actually bought the all the hardware for the portable thermal camera that has like a screen and it uses a teensy 3.6, but that thing was slow. The frames were coming in very slowly. So this is much better. It's less configurable though. I don't have, like, this camera has the information for every pixel. It knows what the temperature is, which would be really nice if I could have something that would show the gradient, like range of temperatures that it has, and possibly identify a temperature as a point source. It's also like heat is getting into the camera. That's why there are these streaks down. Anyway, all right. Let's do some work. We got some work to do here. We'll get to work. Do some work. Get to work. Gotta do work. Ghost gotta do work. Don't get no vacations in Amogus. All right. Soldering iron on. Lots of heat very quickly. A lot of energy just got sacrificed to that. I'm gonna bring over regular solder, because it's not like I care particularly about a lot of the hardware that's on here already. I need to remove the chips. I'm going to keep the headers. I'm going to keep the filters for the USB, I think. But, yeah. Fourier would have loved those. Yeah. Yes, indeed. All right. Welcome to hell. Welcome to hell, little man. Oh, I can't keep that stuff straight. I don't know. Yeah, I don't know which one did which. Which French mathematician did what breakthrough that allows me to have a more complicated engineering degree. Is it transforms or is it... What is it? All right, so because we're just removing stuff, this would be a little bit easier to do with hot air, but I don't want to melt any of my keys. So I am just adding heat. I'm just heating it up. That's all we're doing. We're just adding a bunch of heat. And I'll just one by one remove all of these components and then come through and clean it up again. Now those are diodes, so those stay. C201. Yeah, no, you're gone, buddy. Goodbye. All of you are coming with me. None of you are necessary. New magic gold. I've had that new Gorillaz song stuck in my head for a goddamn solid week now. I don't even know if it's been around for a week. It's just too good of a song. Let's see here. Well, I'm going to be kind of reluctant about getting rid of some of this stuff. This is like power supply conditioning and handling. I don't know what these are doing. Main chip is going to be kind of a beast to remove. Let's see. C203, you didn't even put up a fight. I don't even know what you're doing coming out here to my ring, in my house, and telling me what I can or can't do with pins. You're just a capacitor. Just a capacitor caught up in the fray. I'm losing my mind. All right, let's... It's Friday. I don't feel like doing a lot of programming today, so we're doing hardware now, which is where I have the most fun. But it's good to, like, hey, the software works. And we confirmed that my pin map, at least for the Q key alone, is accurate. That's something to be said, huh? So this isn't chip click that I'm adding regular solder. So there's a chance that this is not gonna just very, very quickly give up the ghost. Where are we? We're like a million miles away. Yeah, once I QQ, I get the hell out of there. I told you what it meant. All right, so we're just dumping a bunch of solder onto the pins. And what that will allow me to do is to have molten solder on all 4 of them. Yeah, all solder is chip quick eventually. The cool thing about chip quick is when you're applying it, you're like, okay, now I just need to apply heat to all 4 of and then the chip pops off. Like, it just pops off. It just gets out of there. It's like, nope, I'm done. Now you can buy soldering iron tips that allow you to do stuff like this. It's a total waste of money. It's like monotaskers in a kitchen. You don't need it unless you're doing 1,000 of these things a day. You do not need a special soldering iron tip to get rid of quad lead packages, you know? But people do it. They insist on wanting to buy stuff in order to do their one job. It's not necessary. It's like, I've got to do this once. I'm actually having a little trouble with it because I can't get the soldering iron positioned in all the positions fast enough, and while remaining visual about what I'm doing. So what I'm going to do is I'm going to add a little chip quick to this. I'm going to add just a little bit of chip quick. Chip quick's an alloy, and this alloy adds to solder, and it severely lowers the temperature that this remains molten. So what I do is just add a little tiny bit of it, and that might have been too much, to each row of pins. That was definitely too much. I'm just going to bring that over to this one. And then finally, let's scoop this a little bit, because I'm gonna eat these very tiny surface mount parts if I'm not careful. So now we've alloyed our metal, and we should, by all means, just be able to pluck this thing up. Now, because we don't care about this chip, I could also individually bend up the pins. That's another strategy that I can go for. Badoo magic gold. I don't even know what the lyrics are. I just like how they sound. There we go. Getting that heat in there, and we're gone. And we're gone. All the noble gases are gone. Tweezers. They're there. Yeah, there's the keys. The keys are still installed, and I don't want to have to uninstall them to do this job, so I'm not using hot air. Hot air you can contain. You can do a decent job containing it. I just don't think it's appropriate for this job. And chip quick, you can kind of pick it up. It doesn't really wick into the solder wick as much as I would like it to, but you can just like pick it up with the solder wick. And since we got a big open area here, we've got plenty of room to play with. That'll of course get a Q-tip cleaning, and then everything will look new. All right, so main chip gone. I don't know what these are doing. Yeah, solder wick is like just it's a need. It's not even a preference. Solder wick is something that you need to have on hand. I don't think I'm going to need chip quick for this one. This is only dual lead package. Control and or power. Yeah, let's just eviscerate, destroy. Okay, get that side. Get this side. This is my super thin solder, so this stuff is probably going to go twice as fast, which means it's only going to last me 2 years instead of 4. All right, now, if I'm going to do this non-visually without the microscope, I would change the view here so that we can see it from the side, because I need to occupy the space right above the chip. So if I do this, and I go to one side, and I give it a little bit of heat for a couple seconds, I come over here, and it's gone. Bada bing. Oh, it resoldered itself. You get over here. We don't need any of the control stuff on the other side either, so... This thing wasn't even dead. This thing probably still works. Gone. Your solder flux splatters? I mean, this is very thin stuff. There's not a lot of flux there to begin with. I don't know. I bought the same brand of solder that I had used previously, just because I liked it. Changed their design a little bit, though. They changed the packaging design. I can't believe it. I hate it now. Bought some solder wick from AliExpress. It doesn't work no matter how much flux I add. Yikes. Listen, man. Chemtronics. Made in the US of A, mofo. This stuff works. Really, is copper ballooning in price? I don't really track a lot of that stuff. These supplies I buy like once or twice a year. I haven't bought solder since 2016. And I just recently had to purchase more to keep the stream going. Feed the stream. Lead-free is expensive. I mean, lead-free is good shit, man. If you're getting exposed to lead on a constant basis, you're going to become a boomer. Start yelling at service people who are just trying to do their job. Those violent motherfuckers have been exposed to lead their entire lives. Hell, even I, as a old millennial, have too. It's bad. It's bad stuff. It really fucks with your brain. That's why my brain don't work no good no more. You guys see me constantly having streamer brain because I've been exposed to lead. When I was a kid, my folks went on vacation without the kids and got a call from the Philly something or other. They were gonna, like, Child Protective Services. They were gonna take me away from my parents because I had just had a doctor's appointment and they found very high, maybe not very high, but they found high lead levels. And they thought that I was being neglected or something, or exposed to chemicals. And the whole thing was a windowsill that I would play in our old house that had a bunch of lead-based paint dust all over it. Maybe that's why my brain doesn't do good. Now the solder wick is getting hot. Stop hurting me. That's really scary. Yeah. Yeah. I mean, it was a simple solution. It's like, you know, it wasn't that bad, but maybe that's why I'm a little crazy. But yeah, we're going to take away, can you imagine? Yeah, we're going to take away your kids. What? Wait a minute, what? Huh? Yeah, the house that we lived in Philadelphia was ancient. I think it's like student housing now. UPenn bought it up. We should have kept that damn house. I think it was worth a lot of money. We moved out to the suburbs, the most stereotypical fucking place in the world. I like living in the city. I like the city. All my friends don't. They don't. I get to bitch about them here. Yeah, the leaded gas that made everything covered in lead. Like, oh yeah, you can go back on the soil sample. The soil, like you could just take a sample and you go deep enough, you're like, oh, there's all the leaded, oh, there's the leaded gas era. Yeah, I think that house is like rife with those kinds of things because it was like, I mean, it even still had fittings for like gas lighting. Not like gas lighting like on the internet. Like, I mean, just like lighting that was flammable gas, right? Not. Stop being crazy, Chad. I don't mean regular gas lighting. Why would you think that I mean regular? You keep coming at me and telling me that it's regular, like normal gas lighting, and it's not. It's like actual lighting with gas. You're being crazy, Chad. You're being crazy. Just stop being crazy for just 1 minute. I mean, this is not right. You're the one who's bringing this opinion to me, and I'd like you to stop. Come here, capacitor. You have no place here in this circuit. I need to add solder. I don't know. I don't have good regular gas lighting is actually lighting with gas. Yeah, there's a new term. That doesn't, you sound crazy. You sound like a crazy person. But okay, for anybody confused, maybe due to a language barrier, I am gaslighting chat. That's the joke. Hey, 512 bits. That sounds like a divisible number. That's an odd number. It's like odd as in weird. But Lime 2186, thank you for the $5 buckaroonies. $5.12. Don't spend it all in one place, kid. Lux lamps. Lighting with propane, huh? Yeah, backcountry huts with gas lighting. Yeah, man. I mean, you know, who's that? Not the engineering mindset. Who's that guy? Who's that Pokemon? No, what's his name? The one guy that does those good engineering videos did a whole thing on the science behind the way those gas lamps are made. It's pretty cool. And people still use them. I think that's everything I want to remove. If I want to get 12 volt or 5 volts, I can get it up here where there's some filter. I don't know what some of these capacitors are. Oh God, big hiccup. Hold on. Technology connections, yes. I think C206 is the decoupler for the main processor. We don't need that. I'm going to get rid of that one. A thorium Coleman mantle that glows bright white when hit by flame. Jesus. You get to just say thorium all the time. Hey, how does that thing work? Thorium! Get to sound cool. I'm going to get rid of these two. I don't think any of this is necessary. These might have been pull-ups for I2C or something like that. In which case I probably would have wanted them there, but they're too small for me to manipulate. All I want is this filtration and the coils up here, as well as these two capacitors here that are smoothing out the input power. Those are nice to have. They're not necessary, but they're nice. All these little surface mount parts that end up in my dry sponge. Everything will disappear. All right, let's see, like that, and then we're just gonna sop up all the remainder. That way we can see stuff a little better in this area. Once we clean up all the flux garbage. Give me this. Give me that. Give me that. No, drop it. Give me that. Give me. Hey. Hey. I think I got it. Thorium dioxide. Man, it really does sound like sci-fi chemicals. Ah, my dry sponge came out. Wait a minute. Ah! You get back in there. Stupid thing. I probably need to clean that out soon. All right. Let's see. What else? There are the remnants of the dip switches. What'd you just call me? Just call me a dip switch? That I just need to clean up. Any other systems on this keyboard? I think that's it. I think we've removed the brain. So the remainder of this would be wiring up all of the muxes, finding an area that they can exist. They're not going to be on a circuit board, which is not great. It's not ideal. I'll put them on what is it? Captain tape. What is the dip switch for? It's how you select stuff with the keyboard. It's how you do like different layouts and stuff like that. You set up the dip switch in a particular way, and when your keyboard boots up, when the code keyboard boots up, it'll configure the various things. So I have like a configuration where the function keys are a certain way, you know, that kind of stuff. It's a very simplistic way to configure the keyboard. What do we got? Is everybody happy? What's going on down there? Something big. Nope, it's gone. Just a part. Just a part that was left behind. It's weird. I'm guessing that these are probably pulled with the rest of the circuit board, or with the rest of the rows. With the rest of the rows in the columns. That's what I'm guessing, but I think it only reads them on startup, so I'm not really certain about that. I can get some of the connections to the columns through these pins here. I gotta decide where these the muxes are gonna go too. All right, let's clean it up a little bit. I need to use a bit of this stuff. And then one of these. In terms of like the soldering for the hardware, I mean, I guess we'll do that tomorrow. I can start deciding where some of my components are going to go. I got plenty of Max 309s, so why does my chat keep disconnecting? I don't understand that. I keep thinking there's like a bunch of chat activity and it's just reconnecting. Man, that song is an earworm. Look at that. It looks brand new after this. I'll get it in a close-up in just a second. Where did I put them away? I only got one out? I did. I put them away. I only got one of them out. I'm gonna dry up all the all the goof off that I left behind. Gotta make it clean. This clean keyboard. I'm gonna reuse this plug and the USB connections. Those are gonna be the hard ones to solder. I would like for this thing with the reset button to be right there. I'd probably make it a little easier to work with. I don't necessarily need that though. I mean, there is a reset button like thing that there's code that I can put in that'll make the reset button in a particular spot. So I mean, I could put it just nearby to where it's going and use double-sided tape to have it kind of in that area. And then I need 3 of the Max 309s. Let me get that. Max 309. Gorsh, Max. All right, there we go. That's a 308. Oh yeah, they are 308s, aren't they? The 308's the 8-pin. The 309 is the 2 banks of 4 pins. So I need each 3. I have so many of them. I don't know what so many of them in that bin. I also think I have Max 309s somewhere too. Wait, I gotta double check. Why would the higher number one be the one that's split? No, that is the Max 308. Okay, so that's the one we'll use. Too small to manipulate, but not too small to gaslight. Everything will disappear. Oh yeah, one of the cool things about thermals is you can actually see where the big veins are beneath the skin here. And that one running up there. And oh look, that's where they stabbed me in order to get my blood. So that was a big needle that they used. I did not enjoy that one bit. Feel better though. Feel pretty good after that. Okay, so. We have our area that our RP 2040 is going to go in. I got all these connections down here. It's so weird that they had a separate microcontroller. I think maybe originally they had this microcontroller which was hooked up to all the keyboard stuff, and then because they ran out of pins, they didn't want to run, you know, all that stuff over here. It's just so weird. And then of course we've got that and that are going off in this direction. Does anyone really enjoy being jabbed with a needle? Yes. There are all kinds of freaks out there. Don't sell yourself short. Yeah, I know. Like, wouldn't like a leg be better? Shouldn't they be doing like a leg instead of my freaking face? Instead of my arm? It's always the arm, and my arms are like now covered in scars from that kind of stuff. Well, that and having a puppy isn't helping. I mean, that one is puppy, that one is puppy. So so yeah, you see they just have like an I2C connection over to, well actually this might be just like a programming header for the two chips. But there is interconnectivity between these two, but so weird. If we did that, if I showed off my battle wounds, I could do that all day. That's like an all day kind of thing. I don't understand what's happening with this Darlington here. I'm calling it a Darlington array because there's 2 transistors that are doing the backlighting for the entire keyboard. So we've got a big 5 volts, I think, source here that runs over to the other side of the, you know, where the 5 volts comes in on that side. And I think it's just like an array. I think you trigger one transistor and then it'll trigger the other transistor. And I guess I can get a resistor and try to poke the lines to see what percolates when I set it off, but I'll need to put code into the thing for that, I guess. And then we got the Max 308s. Now, where are those going to go? I've got a little bit of space here. I mean, there's all kinds of little pockets of space where I could put stuff. One of them's already used by that. But then, I mean, if I'm I don't think I'm going to locate them locally. I think we'll run wires across the whole thing. But I mean, there is a big open space over here. Like, this is huge. So maybe but this one too. and all these rows and columns are coming back to this location, I'll tap into them in other alternate locations, right? Because we've got the scheme here is, hold on. The scheme here is this thing. Oops. We've got the rows that are going directly to the microcontroller, and then the columns go through the diode, and then the switch is in the midst of that. So I need to pick up the columns on the one end of the diode, and then the rows, I don't know where I can get them. I can grab them on the pins to the switches. That's maybe, or you know, get them on the switches, or find somewhere that there's like a test point, or like a, maybe I can scrape up the trace a little bit and put a jumper on that. That's probably the cleaner way to do it. I don't want to solder directly to the switches, because if I ever want to swap out a switch, I need to get my soldering iron in there, and then I don't want to wire to. It's not that big of a deal, but it's just that little extra professionalism that I want to bring to a project like this. Where the hell is OBS? Where did it go? Oh my God, it's right in front of my face. All right. So yeah, most of the not most of them, but some of the diodes are going to be jumping points that I can use in order to connect rows and columns. I guess, well, the only problem is I need space here to plug in that header. So I could go, that's going to be too messy. Well, let's determine where these taps are going to be and maybe see where they lie. So we'll do red and blue wires, just like in the schematic, for the rows and the columns. And I've got my MS Paint drawing that's going to give me all the information that I need. So let me get that into a window that I can reference. And I guess you guys can't see my face in this view, which is great. I don't need you guys looking at me. So we'll use blue and we'll use red, just like in the schematic. Try to tamp down the confusion that I will experience in working with this thing. How long am I going to need? I'm going to need like 1,000 of these fucking things. Well, that's all right. That's all right. That's all right. So we're going to try to connect it as close to this area as possible. Oh yeah, it's just Maker Beam, but it works really well. I need to make something that holds the fronts of them, though. Like, I need to 3D print probably something that holds them in the front so that they don't get, like, twisted and everything. Good solution for storing tape. I did it also for end mill holders on the milling machine. I have another one that looks pretty much like this. All right, so our columns and rows, according to my documentation... that one. According to my documentation, I've got all of them laid out like this, and some of them need to be combined too. But let's just start. I mean, 34, 35, 36. We'll go low to high number, I guess. So we'll try to pick it up in the area that we are. The area that we are is actually over here because we're on the other side of the keyboard. So we need to pick up on 34, 35, 36, right? So we're going to start, well, actually, if we're starting with columns, then we need to pick up 1, 11, 12. Luckily, those numbers are very close by. Here's our closest one. Nope. The O key, my old friend. My beloved O key. Yeah, we're going to the O key, huh? OP. All right, so let's take a look at that on the microscope. I don't know what just fell on the floor. Something. Something attached itself to my hand. O and P. Well, there's 0. There's O. So we are connecting to the column, which means that we can connect to the opposite side of the diode. The side that does not connect to the switch, which makes it a nice, easy soldering job. So we'll do the diodes first, and then we'll do the rows. I guess I'm going to change iron tips. This thing is too giant. This giant soldering iron tip. Look at how big this thing is on camera. Oh my god. Okay, we're swapping that one out. Let me get this. My little custom-made iron holder. We'll use the regular, the nubbly pointed one that I like. That one's usually pretty good at maneuvering around normal-sized electronics. Much easier. Okay. Oh, look at the damage down there. Jeez. Well, I don't think the diodes went bad. I think the processor went bad on this thing, so we are replacing it. We'll breathe new life. Ow. This keyboard hurts. All these pads are very sharp. The pins for the buttons. Now, if Short Lurker had his way, he would have me swapping to sockets on this whole thing. I don't know how that really works with all of the switches clipped into the metal frame like they are. Can't tell if I'm tinning this or not. There's going to be a lot of work. So I got my work cut out for me. This is, by the way, typically the part of the project where you put on some streamer who's doing something, and then you watch or listen to that streamer while doing this very boring work. Oh, hey, what's up, Short Lurker? We got it working. Everything works. So I'm just going to leave these leads here. I'm going to leave them here. I'm going to make them go approximately to this area of the board, and we're just going to solder all of them and see what it looks like. In terms of like routing the traces, I could try to do that. I could also use the unshielded stuff and try to run it flat on the board and then use nail polish to hold it down. Can you explain why the diodes need to go? The diodes stay, but the diodes are in there because they prevent the backflow of electricity from making it look like the wrong keys are pressed. I can do keyboard matrix animation. Everybody and their dog has tried to explain this stuff to people before, so there are many good websites that'll tell you exactly why things are laid out in the way that they are. We basically have switches that connect these things, and you can barely see, because red on black is hard to see, but you can see we're pulsing through and then scanning all of these, and what that does is it creates a situation where it might, if you press a couple keys at once, it might look like another key is pressed. So what you do is you add diodes, and now that flow control keeps things from going in the wrong direction, basically. They're a little one-way valve. And it keeps noise down and all that stuff. Anyway, yeah, so, I mean, just look up, like, keyboard matrix animation, and if you find something nice and clean, that'll be your ticket to a good explanation. I don't exactly have the chops to go through it all right now. Next one is row number 11. So going over to here. Now the number scheme that I have going on here, those are pin numbers. So it's pin numbers of the chip. But it's not row numbers. So pin numbers of the chip. 11 is all up in here. I could hook up 11 pretty much anywhere I feel like. I'm going to do the P key for 11 because it's stored in the balls. Like that. We'll just do the P key because it's right next to what we're soldering right now. I'm really tempted to do like a flat circuit thing with this and run all these leads like flat against the board. That would be fun. No, I can't. I just shouldn't do that. I shouldn't do that. I might glue down, maybe use hot glue or something, and just or just Captain tape, and just attach the wire looms. There's gonna be a lot of wires running around this thing. A lot of wires. There's nothing clean about making your own keyboard. I mean, I guess unless you make the entire circuit board yourself. Then it's moderately cleaner. But like if you hand wire a board, it's just a complete mess. It's a total mess. I mean, alternatively, I could pick up a lot of these things over by the chip, and it would be much easier for me to get to. Yeah, all the resistors are for the LEDs. Those are the current limiting resistors of the LEDs. See, all these pins here is where these are where I could pick up especially with the rows. These represent all of the columns and rows and stuff. But that, I don't know, that looks like it's much more dense and harder to solder to than picking them up, you know, in the wide world over at these guys. So, yep. So that's O and P. What's my next one? Go back to my little table here. 1, 11, 12. Pin number 12. Well, 12 is all over the place. 12 I can get from print and scroll lock and pause. That's all the way up here. Print screen, pin 12. Yeah, there's no other places for it, too. Oh, right alt. Nah. I don't particularly enjoy those people. So let's get it from up here at the top and just long wire. I don't know what length I need yet, you know? Yeah, I mean, I could potentially solder to here. I could also scrape up the solder mask and use them as pads. And then that would be pretty clean, actually. But I don't know if I want to do that. And then alternatively, if I was backed into a corner, I could just solder them like this. That is a huge pain in my ass, though. It might actually be a better idea to do it that way, though. What do I have to connect to? God, it's like every pin on the chip. It's like every single pin on the chip. And if I did that, where then would my maxes be? Maybe right there? And it would be a huge cluster of wire going over to here. Whereas with this, I can choose, I can run them up here, because I got to do the whole chip somewhere. I was hoping to just place it sort of in the same area. And then maybe the maxes can go up here. But it's so hard to figure out what pin is what on this tiny little thing. Yeah, which pin? Yes. Yeah, I don't think this is gonna, like, if I go directly to the chip, I don't think I'm cleaning it up very much. I think I'm gonna go to all the keys, and that'll be kind of dispersed, and I can figure out how to cleanly run all the wires around on the bottom of this. But spreading out a little bit is probably a better idea. Probably have more fun spreading out a little bit on this one. Because I also have to get into this area to get into the LED controls too, so. It's a big mess. Pin 12. Print screen, I guess. I mean, our header's like around here. So, any other 12 takers? 13 I can just get from enter, which is right under where we're working. All right, so print screen. Print screen. Hold on, I gotta move some stuff. Move some stuff around. Yeah, so that's right here. So we can just pick that up right there. We go this way. We go this way. We go this way. Nah, you go this way. Decisions. I mean, it'll make more sense when I like start really wiring everything up where it's supposed to go. I'm just doing this as like a visual aid to see where I can run these wires. Make it clean. I don't want it to be too messy. This Code 10 Kilos keyboard is nice and clean. I don't want it to like rattle around when I move it because of all the wires that I've put underneath it. There should be enough room for all the electronics. I mean, this header is so tall that I don't think any of my stuff's coming anywhere close to it. And I want to attach all of my electronics to the circuit board because there's going to be a lot of wires. I don't want to have to flex a big wiring harness whenever I move stuff. Lord knows I am going to fucking spill shit on this and have to clean it off, which is why I was thinking of like, maybe I should use nail polish and just unshielded wires and just run the unshielded wires along the solder mask to get where I need to go. All right, 13. We could use F12, which is right there. So I'll just do that. God, this is going to take a while. I am truly making way too long of a harness out of this, but I have way too much wire anyway. I don't ever use this stuff. I do occasionally. I do most of my test circuits with this stuff, but I got a lot of it. Okay, you guys won't be able to see me tinning this. Oh, because we're in the wrong view. That's the wrong view too. There it is. Now you can actually see the stuff that I'm doing. Then I clip it just to make it nice and clean. And then we solder it to F12, which is right there. Where's that diode at? F12. Where's my iron? It's always when you're using a microscope like this, one thing that you got to watch out for is how you figure out where your soldering iron is, because you're holding something that's 600 degrees Fahrenheit. Boy oh boy, does it like searing flesh. And then you look at the microscope and you don't have much of a view. You have a very small view area. And so I end up waving the soldering iron back and forth, looking for where it is, and end up stabbing myself in the hand. It has happened and it will happen again. It's happened before and it will happen again. All right. Next is pin. Go over to my guide over here. Pin 14. Which is the down arrow. That's the only close place that I can pick up on pin 14. Yep, down arrow it is. Points down at chat. There it is. Down arrow. Oh, come on. What are you doing? What is this? Okay. A little bit of this, a little bit of that. It's oddly quiet upstairs. I don't know what's going on. The dog's asleep. You're just going to mention that, and it's going to be stuck in my head. This looks like it's going to be tedious. This is the very definition of tedium. That's where we're at with the project, unfortunately. I will, well, we'll probably resume this tomorrow. So we got to get as much work done as we can so we can get done with all this tedium. I've almost got a functional keyboard. The other thing that I got to figure out, and I don't know if I'll do it tonight or if we'll work on it tomorrow, is figuring out the backlighting, how we're going to achieve backlighting with the systems that are in place. Like, that one should probably go the other direction. Too close to the edge. Ugh, I can't like position myself properly. It's hot down here. It's too warm. That's pin 14. Hello? Okay, there's pin 14. Sneaky, sneaky. What's next? I need a more powerful microcontroller to do the backlighting. It's a freaking keyboard, and I've got a Pico Pi running it at like 1 billion megahertz. I don't know, man. That was pin 14. We're looking at 15 and 16. Not gonna be 18, 24, and 25 have to be doubled up with 15 and 16. So how are we organizing that? Well, it's gonna be, I think it's time to do the doubling up of the columns. There it is. There's the view that I was looking for. All right. So over here, I've got my master map of the rows and columns. Where are my pin maps of the rows? There's the pin map. So yeah, pin 14 is also going to pin 18, and this should be a 5. This is 5, 5. What the? Oh my God. All right, come here. No. It's supposed to be transparent, but the background, I can't pick it up. It's too small. All right, those are both 5s. Okay, so row 4, pin 14, the one that we just did, is also going to pin 18, which only goes to the right and left shift. So this down arrow, we need to connect to the shift key. It's really weird. So down arrow is also going to shift. Well, the shifts are on both sides. Where else is 14? Hold on a minute. Where else can I pick up on? This is a weird view. That's not right. 14 and 18. 18 there. Where the hell else does 14 go? It should have a bunch of different functions on the board. I mean, none of the rows are too sparsely populated. They all have a lot of pins on him. Spacebar. Spacely populated. Is it really only spacebar? Oh, yeah. Spacebar, down arrow, delete. Huh. Huh. So, and then the other one is just shift. So delete and right shift, we're going to connect to one another. Delete and, okay, all right. Delete and right shift. I'll just use a blue wire for that. Oops, daisy. Messed it up. No. Keep screwing it up. I'm getting tired and it's starting to get sloppy. My chat keeps disconnecting. Why is it doing that? Twitch, get your shit together. My bitrate. Bitrate's good. Yeah, so there's a lot of work that goes into a weird custom matrix like this, unfortunately. At least we figured it out in the end. I wish I had the benefit of having watched one of you guys do what I just did. Yeah, apparently you can't just willy-nilly add files to the directory and reference them and expect them to actually work with the rest of the code. You need to declare them. All right, delete. Delete. Where's delete? Arrows. There's enter over there. Delete is insert home. There's delete. Oh, wow. It's all the way over here. Okay. So we got to sneak in here. We're doing delete and the enter key are being connected to one another because we're consolidating the rows that have available spaces. That needs a little bit of solder. You keep having reconnect issues? Yeah. Yeah, Twitch on Fridays is always a little bit dodgy. A little bit dodgy. Oh, damn it. I wasn't holding anything. I wasn't holding anything. How's it going? Happy Friday. Happy Friday, everybody. I'm actually pretty happy this Friday because we actually got this thing to work. Enter is where? There it is. So the enter key. Oh boy, this one's weird. This one's weird because it's on a couple different areas, right? Which one? Enter goes to this one, D63. D47 goes to the slash key, but not there. The slash key is there. And so that other pin goes under. Oh God, where even? I do not know. Oh, you're on chatty. That's what powers this chat down there, but I'm looking in the regular Twitch window for everybody else. So which one? I mean, okay, if there's a missing enter key here, I guess we should go here, and then we're just, no, but we're on the wrong side of the diode. I need to be on the other side of the diode. So this one clearly doesn't connect to there, because that's slash. This one goes up and around to here. Yeah, okay, so that's this right here. Ginger Root, subbing into tier 1. Hey, thank you very much. Ginger Root, I really appreciate you subbing to my channel. That is very much appreciated. We're kind of in the throes of a keyboard project here, and it's It's a little bit boring, but we got to get it done, so might as well. Might as well. Yeah, here, let's just like thread this around like this. There's like a sharp thing from that over here. What are you doing over here? Get off of this. It's like a sharp edge. I gotta make sure I don't melt this connector too. I'm interested. Take my money. and I shall. Thank you. I appreciate that. I mean, I could just do a little jumper on this. I could actually jump it on the chip itself. That would be another way to do it. Although that would mean that I have these tiny little jumpers there that would potentially short out different pins. I mean, they're not adjacent to one another, are they? No, they're not. They're a couple pins over. So yeah, I can't exactly do that. That'd be kind of funny, though. Jumper. All right, so let's just do one of these. A little clippy. And then one of these. Ow. That actually kind of hurt. Yeah, the muxes are the real kind of change up of this whole thing, just because we didn't have enough pins on the Raspberry Pi Pico. But it appears to be running the muxes fast enough for me to get key presses out of it, which is great. I mean, that basically opens up the whole project. I don't have any depth of field on this setup, so it's hard to judge where my stuff is. All right, tweezers. I'm kind of working upside down on this one. Let's flip that around. That's going to be much more comfortable. So this one is... where's that? Come back around. Where are you? There you are. Unfortunately, this one crosses right through like the main square of the whole town, but that's okay. Lurking a bunch lately, always interesting streams, but I Dunning-Kruger hard if I said anything about anything. Ah, it's okay. That's all right. I appreciate you guys lurking, and VOD people too. You guys are all contributing to my ego. All right. And to avoid any conflicts with plugging in and out USB, I'm just going to put that down right there. So now those two columns are now connected. Now comes the fun part. Because the next column over, which is 15, I'm putting 24 and 25 on. So 24 and 25, and the only place to pick those up, 24 and 25, are at the Windows keys. So those are the two Windows keys. The only place that I can grab them is here and here. So it actually, because they're next to one another, it might actually make more sense for me to get them at the MCU. They're on the corner. That makes it even easier. Don't some keyboard MCUs use muxes? Probably. I mean, there's no reason why they shouldn't be able to. It's just I'm using an analog mux from 1992. So, pin 24 and 25. All right, let's see if we can grab those. Pin 1, 24 and 25 are these two right here with little vias on them. So I need to go to both of those, and then I need to go to, what are we connecting them to? It's weird that the Windows keys are isolated. The two Shift keys are isolated, and then the Windows keys are isolated. 24 and 25, we're putting up to 15. Right arrow key, insert. Not a whole lot going on. 15, right arrow key and insert. Yeah, there's like nothing else on there. This entire column is just dedicated to these two buttons. Oh, I guess I'm not pulling them all the way in there. I did something wrong. Hold on. Pin 6. We're actually sharing with page up and page down. I screwed up. I screwed it up. I've already messed it up. Messed up the whole thing. Yeah. It'll have that 90s chromatic aberration on it, right? When I type. Yeah, the Max 308 and 309, the latest that we have on the data sheet is from like the 90s. So, god damn it, this thing is like, ugh. You've failed me for the last time, dry sponge. All right, listen up. I'm not gonna keep doing this with you guys here. I'll probably put on some music and just fucking like work on this on my own. We're gonna come back tomorrow. You guys can go watch people play games. I'm gonna lose viewers if I keep doing this. Like, this sucks. You guys see what I'm doing. You get what I'm all about. You're picking up what I'm putting down, right? So what I will do is continue this wiring deep into the night, at least when I get a break from the puppy. And then we'll come back tomorrow and we'll do a Saturday stream. We'll hang out and I'll be able to do more of this wiring and we'll see where it gets to. I'm hoping that I can finish this keyboard quickly. I want my keyboard back. But this is a lot of work. This is a lot of work. So we need to put in the work for it. Thank you guys for joining me and being my IDE during all of this programming, right? Like, there were a lot of like little questions that I had along the way that would have taken a long time to solve, and then I get distracted by something and go do something else. So sitting here in front of stream with you guys, helping me through this stuff, backing me up on the questions that I had, good, really good. You guys helped me out a lot. Fine soldering could have become the new I'm just sleeping meta. Well, I don't know. I gotta go roughhouse with the puppy a little bit, and then I'm going to come back down here and just start soldering. And we'll see where we get to. So happy Friday, everybody. I will see you tomorrow. I don't particularly, I don't think I'm gonna raid anybody. I love y'all, all the people that I follow. I'm sure Davies is probably on doing my summer car, which I wanted to do tomorrow, but I'd rather get more work done on the keyboard. I don't know if Flatulent Gonad is conscious right now, but he streamed last night, did a good My Summer Car. And then you have your big popular streamers that are probably doing God knows what. They're probably having a great time of it. I will catch you guys later. Thank you for joining me. Here's the end card. All the stuff you need, social medias and whatnot. And yeah, I mean, you saw it here. You saw what I was doing here. It's just sitting here soldering. So I will be doing that, and we'll come back tomorrow and hopefully have a little bit more of a variety of work to do on this circuit. See you guys later.